Thank you for joining the wearable health monitoring tutorial. I know there's a lot of interesting tutorials to choose from. I think the software-defined radio tutorial probably has the most street value for the hardware they're giving out. But thanks for joining us here. So this will be a pretty fun tutorial. So my name is Shwetak Patel. I'm a professor at the University of Washington. I also work at Microsoft Research part-time as well on a variety of different projects. In particular, the last couple of years, I've been working with Desney and his group on a number of wearable health technologies, those relating to both Band and a new project that we're working on. So today, Desney will be joining me on stage as well, talking about some of our other projects. So Desney is a principal researcher running and managing the medical devices group. Also joining me a little bit later is Alvi and Tony Andrews, who are from the Microsoft Band SDK and Microsoft Health team. So they'll be joining us when we start going into more detail about the tutorial. So the plan for today is I'll give a high-level overview of wearable health monitoring in general, so kind of motivate the need for this kind of technology and where we are in this space. And then we'll have the Microsoft Band team go into more detail about the Band itself, about the SDK, so enabling researchers to take advantage of the data coming out of the Band. And then they'll also talk a little bit about Microsoft Health as well. So this will be kind of the crux of the tutorial, where they'll go into detail on how do you develop on this platform. And then Desney will talk about a new project that we've been working on called Project Aurora, which takes it to the next level for the kind of sensing you could do on body for health monitoring. So the area of digital health and just mobile health sensing in general has been kind of an interesting space. It's evolved over the course of the last decade, and now we're at an interesting period where mobile phone technology, wearable technology, and just embedded systems in general have really changed the way we can develop, prototype, and imagine a lot of these technologies. And really the hypothesis in the community, both in the computing community and in just in the health community in general, has really been around trying to address this interesting kind of this kind of opposing concept of increasing quality of care while decreasing cost. And really the opportunity for mobile health technology and just digital health technology in general is the notion that if you look at a significant portion of the cost for health and administering health, a lot of it is around managing chronic diseases. So the things that people have to deal with for long periods of time, and trying to figure out how you can manage that and also reduce the onset of various exacerbations and having rehospitalizations as a way to look at how can you reduce that and really push the management of a lot of these care to self-management. And also looking at technology that can start to do diagnostics in new ways, diagnosing things that might happen before these things manifest themselves into challenges that are harder to manage later on in life. And technology can play a role in addressing a lot of these challenges, but we're really just at the forefront of that. We're just early in this process in terms of figuring out, well, what is the technology that can play a role here, and what can it really do in this space? If you look at the medical field in general, there's been a number of different approaches that have really been breakthroughs in the health community, in the health industry. So vaccinations has been one, right? So looking at how do you prevent this from happening by creating vaccines that can prevent diseases from infecting individuals. But if you look at other things that have happened in the industry, point-of-care diagnostics is something we often take for granted. The ability to do an ultrasound in a physician's office, or being able to get a complete blood count or a total hemoglobin count within a matter of hours or minutes, we often think about as some things that's fairly easy to do and things that are just normal in normal care. But point-of-care diagnostics really changed the way that you can actually do diagnosis for patients and people that are suffering from a particular disease. And that the ability to do that and reduce the time between the test coming in and a diagnosis being made has really changed how we can actually administer care. And that's actually been pushed to we've been pushing those boundaries even more by looking at just what the mobile phone has enabled. If you think about the computational resources available on a mobile device, you can start to think about the mobile phone itself administering a lot of the point-of-care diagnostic services that we've imagined only happening in a hospital. So if you just look at the devices that you can purchase these days that connect to a mobile phone that really push point-of-care diagnostics out of the hospital and the physician's office into people's homes, I think we're seeing more and more of that happening because of the advent of the mobile device. In fact, a lot of this is driven by looking at how we scale this technology outside the developed regions, looking at how we can get this into many parts of the world where they might not have access to this kind of technology. And so people thinking creatively about how you can leverage these sensing capabilities to basically do diagnostics anywhere, I think has really pushed the boundaries there. This is an interesting conference that TED did a couple years ago. So TED Med was a conference they did a couple years ago where they wanted to highlight mHealth or mobile health technology, in particular physiological sensing using mobile phone devices. So the image on the right is former Surgeon General of the United States, Regina Benjamin. And one of the things that they were doing at this conference was they had a bunch of these different rooms set up where you could actually get a full physical done within 10, 15 minutes, and they were doing that with entirely using mobile phone technology. In fact, the devices and the products on the left and that chart on the left actually are devices that are being manufactured or actually in research that are being deployed that are being used to actually do physiological monitoring solely using the phone itself. Some of them require an attachment, but primarily it's the phone that's doing the sensing. And the idea here was that if you take the traditional physical, the physical that people do when you go to an annual or biannual visit, you can actually move all of that into a mobile device. And so people were actually coming into these mock-up hospital settings and physical settings and then doing their entire assessment using a mobile device. And so you can imagine what that's doing in terms of point-of-care diagnostics by moving it into something that you can actually scale to a variety of different environments. But one of the challenges with this is even though we're starting to push the boundaries in point of care, one of the challenges is still how often do you actually do this measure? So this is still really much grounded in what traditionally we do in the health industry. So the fact that we do a blood pressure measure or we do certain things that happen very infrequently, that's what we're still working with and that's what we're enabling right now. But there's this other class of monitoring that is in the area of continuous monitoring. So the idea here is that instead of having those checkpoints that are every month, every year, or maybe just every week, looking at how can you get physiological data, in fact, data that we may not actually be able to get right now, but with clever, creative innovation, we can start to get at other physiological information off the body in new ways that can start to get at this question of what you can do in the health industry. And just like how point-of-care diagnostics really revolutionized the health industry, I think continuous monitoring is going to be where the next breakthroughs are going to happen. But one of the challenges with continuous health monitoring is that there's a huge technological challenge. If you think about enabling continuous health monitoring, you're really implying that there's going to be some non-invasive way of doing this. You can't just imagine a little device that's always doing a blood prick, for example, that's trying to continuously get that data. You could imagine devices that are inside the body that's getting that, but in some ways, a lot of these technologies are going to have to be non-invasive. So there's still technological limitations, although we're getting past some of those right now. The other thing is that you can't quite apply a traditional HCI process to a lot of the things that you see in the health industry when it comes to continuous monitoring. In fact, you can't really look at current practices to say, well, how do I employ continuous monitoring to basically enable a particular kind of diagnosis or treatment? And part of the reason is that many of the outcomes in the health industry haven't even been evaluated yet, because the technology really hasn't been available to know what you could do with continuous heart rate monitoring, SpO2 monitoring, or a number of other things. So those technologies haven't really been available yet. So we're at an interesting point where we're inventing and developing a lot of these techniques, but we're also working with the medical communities to figure out, well, what are some of the outcomes for this kind of technology? But I think that the continuous capture space is going to be where we're going to have some of these breakthroughs. One of the biggest challenges right now is that typically, when a symptom comes up, or a symptom arises, that's when you start treatment, or when you start to do some of these point-of-care diagnostics. One of the challenges is, well, how do you start to detect this when you're asymptomatic? In other words, before a condition gets to a point where symptoms start to manifest themselves where people can actually notice it. And so I think continuous capture of physiological data can start to handle these situations where you can actually detect these things when people are still asymptomatic. So one example I want to talk about is some work that my group in particular has been doing at the University of Washington, where we've been looking at how do we manage pulmonary diseases. So if you look at the various kinds of diseases that impact the world right now, cardiovascular disease and cancer typically are 1 and 2, with pulmonary being number 3. And depending on what country, those can flip back and forth between 2 and 3. But pulmonary diseases pretty much make up a significant portion of the diseases that we find in the world. And this includes chronic asthma, cystic fibrosis, COPD. And one of the challenges is managing pulmonary diseases is that a lot of these diseases are chronic diseases in that these manifest themselves at some point in life and then they stick around for pretty much the entire lifetime of an individual. In fact, there's not a lot of cures for these things. In fact, some of these are actually conditions that you can help manage, but you can't actually cure. A lot of these things we don't really have a cure for. And the challenge here is that the self-management tools really aren't available for people that have many of these different conditions. And so right now, pulmonary diseases are kind of like what you would imagine how they're treated. It's pretty much in clinic. So if you look on the right here, this is a device called this is a clinical spirometer. It's a device called a spirometer that essentially assesses lung function. So whenever you have a chronic disease in the pulmonary disease, typically you do lung function tests to assess the quality of your lungs, but also looking at ways that if that's improving or degrading over time. But typically this is done in clinic. Often in pulmonary cases, pulmonary exacerbations that happen, there's really not a known technique or method for figuring out, well, what caused it. It's one of those interesting cases where there's some guesses and hypotheses about what might be causing these exacerbations, but in general, it's very specific to the individual or the person. And so often in-clinic treatment really is incredibly unreliable and often not effective when it comes to many pulmonary diseases itself. But this is what we're kind of used to, and this is unsurprising. So most of the care happens in clinic. And so you can imagine what you could do if you had the ability to offer self-management and also treatment that allows you to collect data continuously when people are out of the clinic itself. And so some of the things that we've been working on have been looking at, well, how do you move a lot of the treatment back out of the hospital but into people's real lives and doing continuous monitoring? So the first thing we've been looking at is, well, how do we create a point-of-care diagnostic system that can really scale? And so this is an application that the group's built, which is called SpiroSmart. The idea behind this is actually just using the microphone that is prevalent on a mobile device and using it as a spirometer. So the idea is that you could use this to assess lung function. And so this is a clinically validated application that was built to basically give you similar results that you would get from the same clinical spirometer you would get at a physician's office. But here you can imagine what you could do with scaling it into the homes. But this by itself doesn't give you everything. This allows you to get the point-of-care diagnostic done at the home or in the home, but it doesn't really give you a full picture of the progression of a disease. So the other things that we've been working on is looking at other continuous signals that you might find. So cough sensing is an interesting one. So if you think about cough, if you ask a physician about cough, one of the first things they'll say is, well, that's a fairly nebulous thing. In fact, if you look at cough, that's a disease, or that's a symptom that manifests itself in pretty much every disease you can think of when it comes to pulmonary diseases. And so cough really doesn't tell you much, but that we really don't know that. So a lot of the feedback from the medical community is that, well, we don't quite know what to do with it, partly because we haven't ever really studied it. So in the past, in the research community, people have looked at cough, but they have never studied long-term impacts of what you could do with cough sensing. And so one of the things that we did was we wanted to investigate this. So we built a device that, again, is built on top of a microphone. So it could be on a mobile device. It could be on something like a Microsoft Band. So anything that actually has a microphone, looking at ways that we can identify cough in the environment, in particular cough around the person. So the person that's actually wearing this, we would be detecting their coughs. And so the simplest thing you could do with this is just do cough counting. So when people are coughing in the environment, and in particular, the person using that device. And so one of the things that we did with this was to see, well, what can we build this technology, and can we actually get the results that we need in terms of the accuracy of counting coughs, so getting the true positives and the false positives to the rate where physicians can actually start to do studies with this. So we actually gave this technology to medical researchers, and they basically started to do their own trials with this. And some of the things that came out of this were quite interesting. So the Bill and Melinda Gates Foundation is actually using the CoughSense technology they're actually doing epidemiological studies for tuberculosis. And so the idea behind this is looking at the spread of disease. For TB, it's actually not, it's not a very well-known disease, even though we've had a lot of time trying to study it. We've had a lot of time to look at it. In terms of the spread of it, we really don't have a good sense in terms of how it spread. We know it spread through aerosolization after you cough, and it's spread throughout a community. But is it a super cougher that's actually spreading it, or is it a number of different individuals that have it that spread that disease? So they've been using this to basically do epidemiological studies. But the other thing that they've been doing with this is looking at how you can help manage treatment. So if you're diagnosed with tuberculosis, it's actually a pretty long process for the treatment. The regimen typically lasts 6 to 9 months. And what you do now is you actually go back to clinic to basically see how well that treatment is helping. But one of the things you could do is you can actually look at cough episodes over time. So over a 6 to 9 month period, we can actually monitor how well that treatment's working, and then in real time provide feedback on how they can actually change the regimen as they're working on it. So the idea behind this is that tuberculosis is an interesting disease in that it's often ever adapting. And so a treatment could actually be working really well 3 months in, but 4 months in you may actually need to change the treatment. So this is one way that they're actually assessing the progression of a disease as you're in the middle of the treatment. The third application of this is actually looking at going one step further. And in particular, the Gates Foundation looking at how you can identify acoustic signatures for tuberculosis. So right now, to diagnose TB, you actually either do a sputum test, so you actually cough up sputum and you put it on a vial, or you actually do a blood test. But one of the things that we found is we actually found an acoustic signature for tuberculosis, in particular the cough signature. So what happens is when you have pulmonary TB is that the pooling in your lungs causes a change in the way that the flow comes out of your vocal tract. And it turns out that that signature is very unique to tuberculosis versus pneumonia or other pulmonary ailments. So you can actually do a TB screen without even actually having to touch a needle or even having to do a sputum test. And so this is one way we can start to do continuous monitoring and try to figure out if there's something that we could do while we're screening. And the other aspect of continuous monitoring comes into physical monitoring or activity monitoring, so things like the Microsoft Band enabling this. So the idea here is looking at, well, how can we start to diagnose and help treat things like exercise-induced asthma, for example, where pulmonary function changes over time as a result of high cardiac activity or physical activity. And we can start to look at when treatment needs to start to occur before an exacerbation happens. So the simplest example of this are things like bronchodilators or inhalers. So when you see activity or certain kinds of physiological changes happening and you detect certain cough episodes, and then you can get somebody to do a spirometry measure, you can actually prevent an asthma attack happening well before it could actually happen. All right, so you can imagine what you could do with these continuous monitoring techniques in the process of actually administering the treatment. So this is just one example, a very small example in the pulmonary space, but you can imagine how this could extrapolate and expand to other diseases and other conditions where you can start to get ahead of the symptom itself or getting ahead of the progression of a particular disease. And so if you look at the space right now, so there are a number of wearable technologies that try to assess all kinds of physiological measures on the body. It could be heart rate monitoring, it could be breathing, it could be sleep. But one of the things that's interesting in this space is there are enough of these technologies out there for us as researchers to start to explore a lot of these different places. If you just thought about this 5 years ago, often it would take a research lab building a prototype in their lab, trying to get it robust enough so they can actually do this deployment, work with the medical community, and start to do these outcome studies. But now we actually have a plethora of technologies that we can leverage to basically start to answer some of these questions on, well, does continuous monitoring actually help? And can we start to look at some of the outcomes in terms of the physiological conditions that could help in terms of outcomes in terms of the medical, in the medical space. And a lot of this is also enabled by the tools that are being developed to enable us to get this data into a single store. So if you look at what Microsoft Health or even Apple HealthKit is doing, where these are ways that we can start to gather this information and start to do these trials and do these studies in ways that we can answer some of these questions. And so the focus of the tutorial today is to just show you 2 example technologies where we're trying to empower researchers and developers to start to answer some of these questions on if continuous heart rate monitoring or continuous physiological monitoring can play a role here, and if it can, well, what are some of the things that we can do to build on top of that? So the first technology is a commercially shipping product, Microsoft Band, and the interesting thing about Band is it has a number of sensors that are monitoring physiological, that are providing physiological data about the human body, and the SDK allows researchers to get access to some of that data. And so we'll go into detail about what that data is, how to actually access it, and what you could do with that. And then Desney will talk about kind of the next generation ways of sensing physiological sensing on the body. So a new type of sensing approach that can get an even higher resolution and other kinds of data on the body that can start to play a role in terms of doing assessment and continuous monitoring. So that's going to be more in the cardiac space. So that's that's what we're going to do today. So what I want to do next is we're going to shift gears. We're going to have Ali and Tony come up and start the band tutorial itself. All right?
Do you want to unlock? Can we switch over to this machine? Thank you. Thank you, Shwetak. Hello, everyone. Thank you so much for coming to this session. I also want to thank Microsoft Research for giving us the opportunity to come here and talk about the product that we've built and we're very proud of, and we love to share with you. My name is Ali. As Shwetak said, I'm a program manager on the Microsoft Band, Microsoft Health team. Today I'm joined with Tony Andrews, who's an architect on the same team, and we're going to talk about how continuous monitoring using Microsoft Band can really enable researchers to get data about individuals and use that data in creative ways to not only identify diseases and medical situations, but also to do long-term preventative care and maybe even track the progression of diseases once an individual suffers from a disease. So really quickly, I'm going to give you an agenda of what we're going to talk about. I'm going to start by talking about the Microsoft Band and what is the Microsoft Health. How many people here actually know about the Microsoft Band or actually own? Some people do. Good. The rest of you will probably know about it by the end of the day when you all get one. So I'll spend some time talking about the Microsoft Band Health, and then I'll go in and talk about what are the different ways in which you can interact with Microsoft Band. That's the SDK and the things that we're doing around in that space. And after that, we'll talk about how you can actually interact with Microsoft Health, which is the service that gets all the data from Microsoft Band. Tony's going to help me do some demos to show you exactly how you can do this in very simple ways by using any technology that you're familiar with. So let's start off by talking about the Microsoft Band. Shwetak mentioned that there's a whole array of different devices that are available. Microsoft Band is just one of those devices. It's an all-day wearable device which was built with a few key objectives in mind. It was designed to help you live healthier. It was also designed to help you be more productive and keep you connected at a glance. So you don't have to reach for your phone throughout the day in order to wear this device. So these ambitions of making people be more healthier and giving them productivity features, coupled with the challenges of having a wearable that is in a slim form factor, which is wearable all day, and basically has good battery life. These challenges resulted in a product which we think is a combination of advanced technology and great engineering. Microsoft Band actually has 10 sensors packed into a very small form factor. In addition, it has a full touch display, and we have optimized the Microsoft Band to give you over 2 days of normal use on a single battery charge. So in the field of wearables right now, having battery life is a big challenge. Making things small and flexible and fit into a smaller form factor, that's another big challenge. So today we're going to talk about how Microsoft Band is able to do a lot of these things while managing to be such a small form factor and having all of these cool technology built into it. Let's quickly talk about some of the fitness features of Microsoft Band. This is the living healthier thing that we talked about. What makes the Microsoft Band unique when it comes to health and fitness is that it is far more than just your average step tracker. So you've seen a lot of these other wearables out there that just do step tracking. Microsoft Band goes far beyond what an average step tracker does. It does that by calculating activity levels, also your heart rate metrics, and also determining your sleep patterns to provide you with the whole picture of your health and fitness. So when you wear the Microsoft Band during the day, It will basically track your steps, your calories, your distance, your runs, your workouts, and details about all of those activities, in addition to other things like UV exposure that you have throughout the day. And when you go to sleep wearing the Microsoft Band will calculate your sleep duration, your sleep efficiency, your wake-up frequency, as well as your sleep restoration to get a good idea of what your sleep patterns are like. And while it does all of that, staying behind the scenes with guided activities, and we'll talk a little bit about what guided activities are, Microsoft Band comes to the forefront and enables you to be more healthier and basically acts as a fitness coach on your wrist. So not only does the Microsoft Band passively tracks and gives you value, it actually comes to the forefront with the guided activities to kind of encourage the wearer to go and be more healthier and do more things. So that was about health and fitness and what Microsoft Band does on the health and fitness front. One of the biggest challenges with fitness tracking and all the other wearables out there is that people go and they're really excited and they go and buy these devices, especially around the New Year time. The sale of these devices goes through the roof because everyone has New Year's resolution, I'm going to lose weight, I'm going to be healthier. And by the time March comes along, most of these devices end up in the drawer because people usually, they're excited and because of their whim of their fancy, they basically go in and they buy the device, they don't use it for very long, or they actually get demotivated, or they don't get the value that they think they're getting out of it, so they put it in the drawer. So one of the things that we considered was, how can we drive all the user engagement and continue to drive engagement of our Microsoft Band with the users? So the way we do that is by providing them with features that enable productivity and enhances and improves their productivity. And the way to do that in this day and age with the mobile phones is to provide people with rich notifications, and not only give them the notifications that are coming to their phone, but only give them the notifications that are most important to them, and give them the notifications at the time when they need it the most. So the Microsoft Band does that, and we feel that by doing that, we enhance and improve the productivity of the people who buy it, and thereby we drive more user engagement with the Microsoft Band. So it's been 6 months, and people who actually bought the bands back in October when we shipped it, a large population of people who actually bought those are still actively using the bands. And we know that because we have data from all of our users. And we think that productivity features contribute towards those things. What are some of these productivity features that we're talking about? Things like incoming calls, your text messages, your social media updates, and local nearby weather, etc. That keeps you informed with the things that you care about the most. So if you have the band, you always know what's going on around you. You don't have to reach for your phone. If all of you were wearing the bands, you probably would not be looking at your phones right now. You'd probably just be glancing on the band to know when something important is happening. In addition, we have email previews and we have calendar alerts. So you essentially, know where to be and what to do even when you're on the move without having to kind of reach for your phone throughout the day. And on Windows, with the help of Microsoft Research, we actually brought Cortana, which is your personal assistant right on your wrist. So you can even enhance and have even more productivity by using Cortana right from the Microsoft Band itself. So Microsoft Band collects all of this data, and all that data goes up to the Microsoft Health Service, which processes and does some algorithms on the Microsoft Band data. And then all of that, all of the data then comes down to the Microsoft Health applications that run across all different operating systems. We have applications that run on iOS, Android, and Windows. And all of this data is then visualized in graphs and charts and trends in the Microsoft Health applications, which basically give you an overall picture of your health and basically give you details about your health. Those graphs and charts, along with the on-band experiences that I just talked about, which are the productivity features, we feel like Microsoft Band and Microsoft Health give you a holistic solution for health, fitness, and productivity. So let's take a look at some of the things that we do collect as part of the daily activity tracking of Microsoft Band. So here's some of the charts for daily activity. So if you're wearing the band and doing nothing but just walking around with the bands at the end of the day, or at the end of after using it for a period of time, you will have things like your total steps that you take during the week, during the day, also during the week, the kind of amount of distance that you've traveled, your total active time. So how much time in the day have you been active versus just sitting around in front of a PC or just doing nothing. We also give you historical data about how you're doing today versus the rest of the previous week or the previous month. So that's a good trend that you can actually see how you're progressing on your fitness or activity level. We also give you some goals, and we keep track of how you're progressing against your goals. If you look at the calories, we give you hour by hour count of number of calories burned and the kind of trend throughout the day. Also give you trend over the weeks, over historical period of time. It could be weekly, it could be even monthly calorie burns. And again, we track and give you feedback on your goals, so you always know how much of the goal if you've met, or how often are you meeting your goals. So those are some of the things when you're not doing anything, just wearing the band and going out and doing your living your normal life. If you're more some of the advanced users or the intermediate user of the band, you use some of the features of the exercises and runs, we collect some key metrics which give you good idea about what the exercises are really doing and how they're contributing towards your health. So if you look at this, top left, we have the total duration of a workout. So if you went for a run, this particular individual ran for 35 minutes and 52 seconds, which is a good amount of workout time. 3 times a week, if you do 30 to 40 minutes of workout, that's recommended by the American Heart Association in order to maintain good health. So not only do we, just by knowing how much you're working out, that alone gives you or your doctor or anybody who's concerned about your health a good understanding of if it's too much or too little. Every time I go to the doctor, they say, do you consider yourself athletic, or how often do you work out? I always used to come up with a number without having any understanding. Now I actually have data that I can look at and provide meaningful information to my doctor. Things like average heart rate, this is very important for people who are actually trying to lose weight or who are trying to just be more healthier. So because we continuously track your heart rate during your exercises, we can tell you the heart rate zones that you were in, what is your average heart rate throughout the time. We also give you the high and low heart rate numbers, which is also very important to know how intensive your workout was. Another thing is we basically calculate calorie burn during all of your exercises. We also tell you how many calories have you burned during your workouts, which are coming from fat versus carb. We base that again based on the heart rate measurement and where the heart rate zones are for your particular profile. And last but not least, the ending heart rate and the heart rate recovery, 1 and 2 minute recovery times. If you wear the Microsoft band and you go for a run, when you finish the run, we basically take a snapshot of your heart rate at the end of your run, and then we keep track of your heart rate for the next 2 minutes. Data suggests that how fast your heart recovers in the 2 minutes after your workout is a great indication of your cardiovascular health. So again, these are numbers that previously you would have no idea about. A lot of people have been running, unless you wear polar chest straps or you have all of these other equipment that you carry around with you. Microsoft band basically silently keeps track of all of these things just by you going for a run and turning on the activity on the Microsoft band. I talked about sleep and how we monitor sleep and give you more data about your sleep. This is one of those things that you can do a lot of things when you're awake, and you can be conscious about the things around you, about your own fitness, about your own things that you do. When you go to sleep, unless you pay someone else to kind of monitor you and count how many times you woke up, how restless you were, how restful your sleep was, there was no way. When I'm sleeping, there's no way for me to know what I'm doing unless there is someone else monitoring. Now you have the Microsoft band on you, and if you sleep with the Microsoft band, you'll get all kinds of data. And there's a reason why sleep is the highest used feature of the Microsoft band. It's because of the data that comes back and how insightful it is for people. So what is this data that comes back from the sleep strap? So the single most important thing that the sleep strap gives you is the resting heart rate. So even if you can have all the equipment when you go to the doctor or when you go to the pharmacy and you measure your heart rate, that heart rate is not really the heart rate that is defined as resting heart rate. When your body goes to sleep, your heart basically slows down and it goes down to a certain level. The range of that heart rate tells you how fit your heart is. So here's the chart which tells you if the heart rate is between 40 to 50 beats per minute, and I think this is for male audience. I think for female, the profile is slightly different. It's considered athletic. So if you can maintain a heart rate of 40 to 50, resting heart rate of 40 to 50 over a long period of your life, it is considered as your heart is very, very healthy. So the chances of you running into cardiovascular issues is very low. The other extreme is if you have over 100 beats per minute while you are sleeping, there's definitely something wrong. So that's an indication. If you have something like that, you probably want to go and get yourself checked. Before, you might not even have any symptoms at this point, but because your heart rate is very high when you sleep, there might be something wrong. If it is very low, then there is some underlying heart issues there as well. So again, just by knowing that one number, a lot of people have actually, I had no idea what my heart rate was, resting heart rate was. Now using the Microsoft Band, I kind of know that it's close to 47, and that kind of gives me the confidence that maybe whatever my lifestyle is, it's doing the right thing. Another thing that we do is a couple of other metrics are we figure out how often, what is the sleep efficiency. So how much time that you've been in bed were you really sleeping versus you were not sleeping. When I looked at my sleep charts, I always thought that I was in bed for 7 to 8 hours, so that was good enough for me to sleep. But when I looked at my Microsoft Band historical data, it showed me that my sleep efficiency, even though it was high sleep efficiency, my total time slept, the duration of my sleep was about 5 hours. And that's when I started realizing that just before going to bed, I'm checking my my computer email, I'm replying to emails. Even though in my mind I've gone to bed at 10, I really don't go to sleep until probably midnight. And then when I wake up, as soon as I wake up by the alarm, I start checking emails again, or I'm doing other things. So even though the time I spent in bed was far longer, the duration, according to the Microsoft Band, because it can detect when I went to sleep and how long I was sleeping, was not enough for me to consider my sleep as a good sleeping habit. So I've been working on that personally to kind of get more sleep and spend less time in front of the PC when I go to sleep. So those are just numbers that, without you having to do anything, Microsoft Band just passively tracks those and gives you information and insights about these. Let's talk about observation and insights. So I briefly touched upon this, but this chart will help kind of visualize the concepts a little more. So at the very bottom of the stack is the Microsoft Band hardware, which basically has all of the sensors that I talked about. So these sensors are getting all the data about the person wearing the Microsoft Band. Then these sensors feed data into the software running on the Microsoft Band. And we talked about how there are certain things like, that fall into the buckets of wellness versus lifestyle versus day classification, how much time you're sleeping, walking, exercising, those kinds of things. These give you data about yourself. So getting the data from the sensors, feeding it to the Microsoft Band software tells you about yourself. While that's good enough for a lot of people, a lot of other people like to know how they're doing versus everyone else in their group. So that's where the Microsoft Health service comes into play. We get data from all different individuals of all age groups, of different height, weight, and gender profiles. And we can basically bucketize them and kind of give you a feedback about how your numbers stack up against other people. So things like your resting heart rate versus people in your age group, or your kind of with similar patterns of exercises, that is another indication of you, how you do versus the rest of the people. So by using the Microsoft Health service, we can take you to the next level of giving you feedback about not just yourself, and basically by comparing you to everyone around you and giving you some actionable insight on what things you can do to improve that number, or basically just give you positive feedback to say that you're doing a great job and keep it up. So those are all the features of the Microsoft Band. So when we shipped the Microsoft Band, as the first thing that we got feedback from the broader community was, this thing is great, it has all these sensors, how do we get access to these sensors? So you're doing all of these calculations, you're getting all of this data, how do we get access to this data? So immediately after shipping, we started looking into ways in which we could enhance the experience for other third-party developers to bring them into this ecosystem. The first thing that we did in order to achieve that is the Microsoft Band SDK. So today we're going to talk about the Microsoft Band SDK and also do some demos to show you how you can use the SDK to get some of the data from the Microsoft Band. So what is the Microsoft Band SDK? In a nutshell, Microsoft Band SDK's purpose is to allow third-party developers to enhance and extend the experience of their applications by getting data from the Microsoft Band. So in a nutshell, what Microsoft Band SDK does is it opens up the Microsoft Band for applications by abstracting out the communication layer between the band and the phone. And basically, it exposes the Microsoft Band as a programmable object. So if you're writing some code, all you have to do is basically create a namespace and drop in a namespace, create a Microsoft Band client. Once you have the band client, you can actually just call functions on that Microsoft Band client and get data from the Microsoft Band. Once you have the band client created, there are three basic modes of interaction that you can do with the Microsoft Band. You can stream data from the Microsoft Band sensors. So I said there's an array of sensors on Microsoft Band. Everyone wants to get data from those, real-time data from those sensors. So the Microsoft Band SDK will allow you to do that. Another thing that you can do with the Microsoft Band SDK is you can create interactive tiles. So once you get data from the Microsoft Band, you want to give some feedback or some information back to the person wearing the Microsoft Band. You can do that by creating the interactive tiles on Microsoft Band, and then you can actually get data from within those tiles back. So you can build an experience with the Microsoft Band which will be more interactive with the user. The last but not the least, and this is not probably very interesting for you guys here, but the third-party developers really love this. You can personalize and customize the Microsoft Band. So basically, you can change the look and the feel of the Microsoft Band and give your users the ability to change how it looks according to their own preferences. Before we talk in more detail about the Microsoft Band SDK, I want to highlight one key point. Like most wearables in this category, Microsoft Band is not very different in the sense that it does not provide an application platform. So you're not writing applications against the mic. This is not another platform that you have to write against. You always have to write an application on the host platform, and that application, that's where your application code runs, and that application can use the Microsoft Band as a rich sensor input mechanism as well as an auxiliary display. So you're not developing for an application that runs on the Microsoft Band. You're developing an application that runs on the phone or the PC, whichever one you choose, and then that application can just basically connect to the band and get data from it and send data to it. So let's talk about the three things first of the three ways in which you can interact with the Microsoft Band, which is the Microsoft Band sensors. So using the SDK, you can connect and subscribe to Microsoft Band sensors. We call these as sensor streams. So as an application, you can actually subscribe to one of these streams. So you can subscribe to the heart rate stream or any of the other accelerometer gyroscope streams. Once you actually subscribe to this stream, the Microsoft Band SDK will then invoke callbacks into your code every time there's new data available from that stream. Once you have that stream, then you can make that, every time new data comes in, you can make decisions based on that data. Some of this data is going to be very raw data. Some of this data is going to be data that is curated by the Microsoft Band, and it basically gives you not the raw values, but actually values that are more meaningful to you. Let's look at some of the sensor streams that we expose. So here's a table that kind of talks about all the sensor streams that we support right now. The left-hand side is the sensor the stream that we expose. The middle column shows you what is the reading that is coming back and what is in the payload that comes back when you actually subscribe to this stream. And on the right-hand side, it tells you the frequency of how often or how frequently you'll get data from that stream. So as an example, if you look at the heart rate, we give you the number of beats per minute. So once you connect to the Microsoft Band, you can actually get the number of beats, which is the heart rate of the wearer. And we also give you a reading quality, which is essentially whether the reading is locked or we're still in the process of acquiring. So in order for you to make a decision, a more educated decision about that heart rate value. And we give you that data once every second. So once you basically subscribe to the heart rate sensor, every second you can just basically now get the data from the wearer. This is what we do when you're running or when you're doing an exercise. The Microsoft Band actually internally is also consuming the heart rate data once every second to build those nice charts that we showed you about, your heart rate, average heart rate, max heart rate, lowest heart rate, and heart rate recovery, etc. The other sensors which are very useful are the accelerometer and gyroscope. These are the inertial and motion unit on the Microsoft Band. Basically, we give you the X, Y, Z values for the accelerometer as well as the gyroscope. And we give you different frequencies, so you can get data in 60 hertz, 30 hertz, or as low as 8 hertz, depending on the kind of use case you want to do with the Microsoft Band. Some of the other things, these are curated values. Now, distance, for example, is a curated value. So if you want someone to just go and take a walk and you want to know how far that person has walked or run, you can actually subscribe to the distance subscription, and we'll tell you the total distance. We'll also tell you the speed at which the person is walking, what is the pace in terms of milliseconds taken per minute, per meter. And then the pedometer state, essentially, if you're running or you're not running or you're idle or you're just walking. And we again give you that data once every second, so you'll continuously get that data every time you need it. Other things like pedometer, basically just tells you the number of steps. That's good for step counting. Skin temperature is basically current skin temperature in degrees centigrade. Anytime the temperature changes, you'll get the value. In fact, I think the skin temperature we give you once every second because it can change more frequently. Same with the UV sensor. If someone is outdoor and is being exposed to UV, you can subscribe to the UV sensor and get data. The band contact sensor is a good sensor to know when the user is wearing the band or not wearing the band, to make some assessment or turn off some algorithms on your side. And the last but not the least, the total number of calories is very similar to total number of steps. Basically tells you how many calories the person has burned since the time you started the subscription. A couple of things to keep in mind. The phone has to be connected when you're doing the streaming. If we're doing streaming over Bluetooth, so as soon as the band goes out of reach from the phone, the streaming will stop, so you won't get the data. It's pretty obvious, but some people don't. They think that it's going to continue to collect data. Some sensors will require explicit user consent. It doesn't matter for researchers, but third-party application developers, for example, we don't want someone to write a flashlight application and silently listen to your heart rate or other things that you don't want to give consent to. So the user has to authorize, and they only have to do it once to give authorization to the app to get the data. And last but not least, the battery. We do have some battery impact when you're running long-running subscriptions because you're using Bluetooth and you're running code on both sides. If you have very long-running subscriptions, you have to be wary that the band battery will not last you can't do that for 2 days. You can do it for 4, 5, 6 hours, but if anything beyond that, you will probably lose the band's battery. I think we have a time for a demo. I'm going to hand off to Tony, who's going to do a quick demo of showing you how you can use the Microsoft Band SDK to connect to the Microsoft Band and get sensor data from the Microsoft Band.
Okay. So we're going to go build an application, and don't worry, this will be painless. I'm going to do the demonstration using Visual Studio, so we're going to make an application here. We'll run it on a Windows phone. But as Ali was mentioning earlier, we do support all of the phone platforms. And in the demo area later, if you're interested, we can look at Android code if you want to see how that works. And if you're an iOS developer, you can work on that platform as well. Let's see, how do we switch monitors? Oh, PowerPoint is still grabbing the display. Okay. 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 So we're in Visual Studio, and we're going to go make a new project, and this will be a blank application. And I'm going to avoid going into lots of the nuts and bolts on the code here. I know that's probably not what most of you are interested in, but we kind of want to give you a sense for how easy it is to hook up the SDK and start collecting data from the band. And in the next demo, we'll look at how to do some interactive scenarios and create custom tiles. So I've created this new project, and the first thing I'll do, we'll do this on the phone. So I'm going to make that my startup project. And then there's a NuGet package that has the SDK, so we'll just go search for that. And we'll just pull that into our application here. Okay, so we're ready to go look at some code. So we're going to make a really simple UI here. And I'll just drag in some controls. So this is what the UI for our application will look like. So we're going to have a status area here, and we'll use that to just show what's going on within the application. A couple of buttons to start and stop the heart rate sensor, and then this is the area where we'll show the actual heart rate reading. Okay. So we'll go look at the code behind this now. So Ali mentioned some namespaces that we'll be pulling in here. So here are some of the namespaces related to the band. And then we talked about using or accessing the band through as an object. And so we're going to pull in a member here to our class. This is the iBand client connection that you saw Ali mention earlier. So in a moment, we'll see how we connect that to a band and then communicate with it. So we'll just come down here to the on-navigated to method for this application. So this is where we're going to drop in most of the code. And the first thing that we want to do is just enumerate the bands. So we're going to use this band client manager. We'll get the singleton instance on that, and I just need to make that async. And we'll call this method called getBandsAsync, and that's going to go out, find the set of bands that are paired with this phone. Now normally that's just one, but you can pair as many bands with the phone as the Bluetooth stack will allow. So you could have any number of bands paired there. And there might be scenarios where you actually want to have multiple bands talking to a single device. So we get the set of bands back, and then we're just going to go select the first one, or we'll get null if there are no bands there. And if we don't have any bands at all, we're just going to print a status message there in return. But in the normal case, what we want to do next is connect. So we'll use this status area that we set up there for this purpose, and we'll note that we're connecting. And then we'll go back to the band client manager, back to our singleton instance, and tell it to connect. And what we're connecting to is the band that we selected, the first paired band. Okay. So now we've got the band, we've identified a band, we've connected to it, and the next thing we want to do is get set up to start reading the heart rate from the band. And so Ali mentioned that we need to get the user's consent for this. So there's a little bit of code that we need to do that. And remember that we only want to ask for this once. So we're going to remember that. Actually, the SDK remembers if the user has previously granted consent. So the first thing that we want to do is go check that. So we go, now we're using our band client. We're talking to this specific band that we've got an open connection to. Now we use the sensor manager and go to the heart rate and ask what's the current user consent setting there. So if the user has previously declined consent or granted, then we've got our answer and we're done. But in the first time case, what we'll get is not specified in that setting here. And in that case, what we want to do is go back to the heart rate sensor and request user consent. And what that's going to do is just pop up some UI that tells the user that this application is requesting to access the heart rate monitor and ask the user if that's okay. Okay, so once that's done, if we've gotten consent from the user, then we now want to go set up an event handler, and this is the callback that Ali mentioned earlier, the callback that's going to happen every time there's a heart rate change. Or actually, in this case, it's going to be on a 1 hertz basis. So when that happens, we've got this inline method that's going to be called, and what we're really doing is just going back to the main thread, and the heart of this is that we're just going to set the heart rate field there in the UI, and we're going to just format a string that's based both on the quality, and we'll see what that looks like in a moment, as well as the actual heart rate reading. Okay? So now we're all set up for, once we're reading heart rates, what are we going to do with that? And now we just need to wire up a couple of event handlers for those buttons. So we have the start and stop buttons. So in the case of start, we just want to say start readings and stop readings when they press the stop button. So we're all set, the application's ready to go. So we'll run that on our phone here, and let's switch this monitor over to the overhead camera. Do we need to do anything up here for that? Okay, there we go. So we've got our phone. I'm going to start the application building. The application will deploy and run here on the phone in a moment. And in the meantime, I'll put this band on. Okay, so the application's starting up now. And you see it's connecting. And now we've got the consent UI. So I'll grant consent. Now we're connected and we're ready to go. And actually, I don't need to hold the band there because we aren't going to see anything on the band display right now. So, starting. Okay, so it's acquiring. So it doesn't have full confidence, or it's not completely locked on because I just put this on and we just started up the sensor. In a moment here, we'll see what my current heart rating is once we've got a good lock. And I'll just give it a few seconds. Should take 10 to 15 seconds for that to happen. Acquiring. There we go, locked. So the demo's going pretty well. I'm pretty relaxed. My heart rate isn't too high, so that's all good. So far, so good. So we'll just stop that. And that's it for the first part of the demo. So we'll come back to this in a little bit here once Alia's talked a little bit more about some of the other features of the band and the SDK. So we'll go back to, you want to extend here now, right?
It probably automatically does it.
Okay.
Right, thank you, Tony. Yes? You can pair the band with your laptop, but you won't be able to run the app on the emulator because the emulator does not have Bluetooth support to connect to the band. So you'll have to kind of deploy it. If you pair the band with the PC, you can actually just run the app. If you write an app for the PC, you can actually just run it from there. But the phone emulator on the Visual Studio on the PC will not have the Bluetooth support. That's correct, right? Okay. So Tony just showed you how you can actually use the Microsoft Band SDK in your application, and we wrote an application within 5 minutes of basically getting the SDK, using it to connect to the Microsoft Band, subscribing to a sensor stream, and getting the sensor data back. So we only showed the heart rate sensor, but all the other sensors that were shown in that table, you can actually, with pretty much the same amount of code, you can actually get all of those sensors as well. And if later on, when we're in the demo area, we can actually show you sample apps which are actually doing that, getting accelerometer, gyroscope, skin temperature, other data from all the other sensors on the Microsoft Band. One thing you must have noticed was, Antonio was saying that he doesn't have to show the band because the application at no point put anything on the Microsoft Band. All we did was we wrote an application that ran on the phone, it connected to the band and got the data from the band sensors. So that's good if you're getting data from the band. If you want to send data and use the Microsoft Band and the nice full touch display as a secondary display on the Microsoft Band, you want to create tiles on Microsoft Band. The SDK lets you do that. So the SDK, once you downloaded the SDK and connected to the band over Bluetooth, you can create your own tiles on the Microsoft Band. Once you've created those tiles, you can send notifications and dialogues into those tiles and also get notifications back from those tiles. So this is when if you're subscribing to sensors and getting data from the sensors and you want to give some feedback to the user, or if you just want to write a cool application that just sends periodic data that you get from some other source onto the Microsoft Band and use the band as an auxiliary display for the users, this is where basically you can create tiles and send data into those tiles. So how do you, what are these tiles and how do you create them, or what is involved in those things? So once your application is talking to the Microsoft Band, your application can create one or more tile on the Microsoft Band. Each one of these tiles is very easy to create. All you have to specify is a GUID that identifies that tile, and you basically also specify a couple of icons that show up on the Microsoft Band so that to identify your tile. If you don't even specify an icon, it'll show up as a blank, but I don't think the SDK allows you to do that anymore. A tile can actually have 8 additional icons that you can use inside of the pages. So when you create a tile on the Microsoft Band, that's the thing that shows up as on the home screen. Once the user taps on that tile, you go into the contents of those tiles, and the content of the tiles is defined as pages. A tile can have up to 8 pages. Each one of these pages, okay, come on, there you go. A tile can have up to 8 pages. Each one of these pages has a viewport which is already defined, and it's vertically scrollable. So you can send data into a page and the user can scroll vertically to kind of see more data. If the user scrolls horizontally, the user will navigate between the pages, between one of the 8 pages. So you can go back and forth and send data over there. How do you create these pages? So you've created a tile using the Microsoft Band SDK. Now, in order to create a page on the Microsoft tile, you can actually, Microsoft Band tile, you can actually send it by sending it a messaging notification, or you can create these pages by creating your own custom layouts. And we quickly talk about how those, the 2 different ways of creating tiles and sending data into those tiles works. So the first thing I talked about was you can send messaging notifications. So what are these notifications? On the Microsoft Band, once you have a tile, you can send 3 main types of notifications. The first ones are what we call messages. These are title and body style notifications. So this is like your SMS or your Twitter or your Facebook style notification that has a header and a body. The body basically wraps around and you can scroll. So every time you send a message into your tile, it shows up as a page with the title and a body. You can send up to 8, like I said, you can have 8 pages. The good thing about these is you don't have to worry about which page shows where. It's a chronological order, first in, first out. So as you keep sending pages, they just kind of keep adding on. And when you send the 9th one, the first one goes away. So this is like a continuous way of communicating and sending messages to the Microsoft Band wearer. Another way in which you can send notifications to your users are through dialogues. So dialogues are identical in pretty much the way that messages are, except that messages persist inside of the tile as pages. Dialogues just show up with a line 1 and a line 2. And basically, once the user dismisses the dialogue goes away. It doesn't persist, so you never see that again. So this is just to give instantaneous feedback about something, and then you don't want that feedback to persist. That's when you use the dialogues to send a notification. Third way to do that is by using haptic alerts. So one of the things that a Microsoft Band has, it has a vibration motor built into the Microsoft Band. And the SDK allows you to control that vibration motor by sending a predefined list of 9 different types of vibrations that you can send. And those vibrations will basically just not show any UI. It will just buzz the band, and you can play around with the different vibration types to inform about different feedback to the user. Just before I came for the summit, somebody sent us a initial prototype of an application where they were using the Microsoft Band on a Parkinson's patient, and they were using vibration alerts to kind of give them a cadence for when they start walking. So without the band, they were not able to walk, or they would just pause. By sending them continuous pulse at a given interval, they were able to make the person continue to walk in a straight line. And every time they would stop for an extended period of time, the application was able to figure out that the person is not walking, and then it will start sending you vibrations. To a point that after the person started walking, even if you take away the vibration alerts, they kind of established a rhythm where the person continued walking. And when they detected that the person is no longer walking, they would send it again. So at the surface, it seems like, okay, what are these vibration alerts going to do? But when I saw that, there's a very practical example of where it really can make a difference. The key thing is that vibration alerts will not send any UI. It's just a notification that comes through the haptic motor. So that was one of the ways of creating pages onto the Microsoft Band, by sending a messaging notification. Another way is if you want to send more data, which is a little more different than just a title and a body. You want to lay it out in multiple text fields, or you want to send icons, you use custom layouts. A tile can register up to 5 layouts when you create the tile. When you create the tile, you can say, okay, here's my Microsoft Band tile, and this tile is going to show data in these different layouts, and you send those layouts over. And we will show you exactly how those work. Each one of these layouts is basically a tree where you have container elements which define the position of different content elements. So you can actually say, okay, on the left-hand side, I want to show in one container element, I will have an icon. On the right-hand side, I want to have a container element that just contains 3 different lines of text. So that's one custom layout that you can create. You can play around and create multiple layouts using the container and content elements. If you've ever worked with XML documents, it's very simple to build. You start off with the container elements, and you continue to add content or container elements inside of them. The container elements, like I said, you can have one or more content element inside of them. There's a table of what are the container elements. They could be a flow panel, which basically just is not scrollable, but in a fixed viewport. You can also have scroll flow panel, where you can say, okay, the content inside of this container will flow horizontally or vertically, and you can just have a filled panel, which is just a static panel with some fill color in them. The content types we support are, you can have text, icons, barcodes, and buttons. There are different types of buttons, also different types of text blocks that can wrap, which you'll obviously use if you're using a vertical scrolling container. And then buttons, you can actually have text on the buttons, or you can also have just buttons which are solid filled buttons, like red or green, just colored buttons. These elements support, like I said, they support positioning, formatting, and styling. So you can essentially, using these custom layouts, you can position exactly the way you want your layout to look like. The examples on the bottom right are 2 of the examples of custom layouts that we use inside of Microsoft Band. So the one on the left has 3 icons, and each one of those icons actually has a text label associated with it. On the right-hand side, you have a couple of text blocks on the top with different styling, and then you have a big icon with a large font text block on the right-hand side. You can probably guess what that is being used for in the Microsoft band. So once you've created a layout or defined a layout, you can use one of those layouts to send a page to the Microsoft band. So the title and the body style messages is one kind of page. Now using the layouts, you can send a new kind of page. What are these pages and how do you send these pages? So it's a simple addressing schema. You have your tile which has an ID. Inside of those tiles, you have 8 pages, and you can define the ID of those pages. And within each of those pages, you have elements that you just defined in your custom layouts. Those have their own identifiers for each one of those elements. So if you defined a layout with 5 elements and you call them 1, 2, 3, element 1, element 2, 3, and 4, and 5, you essentially, when you want to create a page, you will choose your layout, and you'll say, okay, the layout identifier 1, here are the 5 which contain those 5 elements. Here are the values for those 5 elements. Once you've created that page, that page is ready to be sent over to the Microsoft band. The type of values or the content that you show, it's pretty obvious. For text blocks, you'll actually have the string that you want to show in that text blocks. For icons, you will send us the index of the icon. So in the beginning, I said that the tiles can create, when you create a tile, you can send up to 8 additional icons in addition to the 2 that are required. So you'll basically tell us the index of which icon you want to use. For barcodes, you just send us the string representation of the barcode, and we'll just create the barcode for you. And for button, you basically just want to show the string for the text button, and for the fill button, you just want to show the color that you want in that button. Once you have a page, you just send the page by defining an ID for that page. If a page with the same ID already exists inside of your tile, what we do is we basically update that page. So this is a way of updating your pages on the fly. If you want to add a new page, you send a new page GUID. If there's a page GUID that already existed, you can just update the same page. So you can have a tile with just one page, and you can continue to update data inside of that page by sending a new page with the same ID. The previous screen, I showed layouts that we were using on Microsoft band. These are the instantiations of those layouts as pages on Microsoft band. So the left-hand side is essentially a summary of a run or a walk that you took, and it shows you the total amount of time denoted by an icon, and then the distance as well as the pace in which you're running a mile. On the right-hand side, the layout is being used for basically the weather tile. So it shows you whether now, or it could be today or tomorrow, Wednesday, Thursday, or whatever. And then the kind of weather conditions, the icon tells you a visual representation, and the temperature shows you the temperature that it is that you want to show. So that's the previous screen showed you the layout. This is how the layout would look like with some data in it. So once you create tiles on Microsoft band, now we saw that you can get data from the Microsoft band sensors. Now you're like, okay, based on those sensors, maybe I'm going to send some data back to the Microsoft band. So you created a tile and you sent a page to the Microsoft band tile. Maybe that page has a button. Now you want to know when the user actually went into my tile, and if the user has pressed that button, so that you know that the data that you sent to the band, the user has actually taken an action on it. So basically, we support 3 different types of events that you can subscribe to on your tile. These are very simple to understand. We tell you when the user opens up your tile, you get an event in your app. When the user closes your tile or basically gets out of your tile, you get an event. And whenever a button is pressed inside of that tile, we will send you an event with the button identifier to tell you which button was pressed. So if you send some data over and you basically asked a question which was a yes or no question, when the user presses the yes or the no button, your application will know that that button has been pressed. For people who actually work with different platforms, just a caveat here, events are handled slightly differently per platform. So on Android, we use broadcast intents. So if you're writing code in Android and working with the Microsoft Band SDK, your application will get callbacks whenever the user taps a button on the tile that you've created. It doesn't matter if your app is running or not running or is terminated. As long as the app is installed, you will get a callback. So that's great on Android. On iOS, we use Bluetooth Low Energy custom characteristic. That kind of limits us a little further because you can only get notification when the app is actively running or if it's in the background. If the app is not running at all, if the user has terminated your app, then you won't get the notification. So it's a little bit of a limitation, but for research purposes, yes, sir.
Yeah, can I ask what happens when it's out of range of the phone? Can you batch up reading or batch up interacting?
No. Yes, it has to be connected and be in. It doesn't have to be. It has to be paired and be in range. We can initiate a connection on demand from the band, But it doesn't have to have an active connection, they just have to be within range to create a connection. And on Windows, we use direct communication. The way the Windows application model works is as soon as the application goes into the background, Windows actually aggressively suspends the app, and there is no way for a suspended app to be woken up. So you will only get your callbacks if the app is either in the foreground or if it is running in the long-running task in the background. So as long as the app code is actively running, you will get data back. With Windows 10, we're actually going to change that because Windows 10 provides some mechanisms to wake up. Just like on Android, you can have intents. On Windows, you will have app services, and those app services can wake up applications in the background. One of the last things that I wanted to talk about was, and I mentioned this is not very interesting for research purposes. The SDK allows you to personalize and customize the Microsoft Band. So using the SDK, you can change the wallpaper as well as change the color theme of the Microsoft Band. So what is the wallpaper? The wallpaper is the Me tile. This is a tile when you power up the Microsoft Band, the first screen that you see on the Microsoft Band, that's the Me tile. That screen actually has a background. You can actually, using the Microsoft Band SDK, you can change that background to whatever background you want. A lot of people actually, there is some white space on the top right corner. People have actually used that space to kind of send some data that they want the users to always be able to see. So people have done creative things to use the wallpaper as a canvas where they can actually project their own content. The second thing that you can do is you can change the color theme of the Microsoft Band. Microsoft Band has 6 different colors that it uses to basically differentiate the different states of the tiles. The 6 colors together become a theme. You can actually define your own theme, and you can set that theme on your own tile. You can also, using the SDK, change the theme for all of the Microsoft Band tiles. A lot of people like to change the theme based on the clothes they're wearing. So there are a lot of apps that actually let you do this, and people really are fascinated by these things. Not very exciting for research purposes, but for usability perspective and driving user engagement and getting people engaged and continue to use Microsoft Band, these things are very cool. So we saw how you can create sensors, create band client and get sensor data. Now we will tell you how we can create an interactive tile on the Microsoft Band. Tony.
Okay, so we'll go back into Visual Studio and we'll just kind of pick up where we left off. The demo I'm going to show you was built originally for a talk we did a couple of weeks ago at a Microsoft Developer Conference. And the demo we were doing was ultimately to show a home automation scenario. So we wanted to make a tile with the name living room light and then on-off switches. And at the end of the demo, we actually had some home automation equipment and showed lights turning on and off just by pressing the band. In the context of this talk, I think it's more interesting to think about how you might leverage these capabilities in the context of health, possibly giving users a way to kind of log interesting events through their day, or maybe make a note of their pain level through the day, or maybe to give them reminders about medication or other activities that you'd like for them to perform as part of their health regimen. So let's go back into the application here, and I'm going to drag in some code that creates a custom tile layout and then initializes the tile. So I'll drag this in, and then we'll just take a quick look through that code. So let's scroll up here a bit. Okay. So this is a method, create or initialize tile, that we're going to be, we'll add a call to this in a moment. The first thing we're going to do is just set up those GUIDs. So we're going to make random GUIDs for the tile and the page that we're creating. So we're going to go to the first thing we want to do is see, have we already created this tile? So again, this is create or initialize, so we might not be calling this just on the first time, but we'll be calling this every time the application launches. So we're going to get the tiles that we've already added to the band. Again, we're just going to look at the first one, and now we're going to do this initialization process only if we don't have a tile there already. Okay. So for this demonstration, the layout on the tile, on the page that we're going to create is just going to be those two buttons that I mentioned, on and off. And so we use a flow panel to arrange those horizontally across the page. So we create the flow panel first. We want to align that horizontally, and then we'll just center that whole panel within the page. Okay. Now we've got the panel, we can put those button elements into it. So we just go to our elements collection. We're going to add to that. So first create a text button. We'll give it element ID 1. We'll set its width to be about half of the available space. And then we'll set its pressed color to be red. This is going to be our off button. Okay. And we'll just give it a little margin there to separate it from the next button. Okay, very similar code here for the second button. We'll give it a unique ID here, and we'll use a green color for it, and that'll be our on button. Okay. So now we're ready to create our whole page layout, and we'll just set that flow panel to be the root element of that layout. And now that we've got our layout fully constructed, we can go make the band tile itself. So we'll use our tile GUID to initialize that, and we're going to set the name. Build was the name of the conference we were doing this demo at a couple of weeks ago. So it's our build demo, and we're going to load up a couple of icons from our application resources to identify that tile. Okay, so we've initialized the tile. Now we'll go add our layout to the tile. And now the tile is fully constructed. We can go back to the tile manager, and we'll just add that tile. Okay. Now, that was all within that if statement, so that was all things, that's all code that we're only going to execute if the tile isn't there. Now, every time we initialize the application, we're going to go provide that page data. And in this case, what we need to provide are the labels for those buttons. So those, in real examples, the content of those buttons might be dynamic. But in this case, it's always just going to be off and on, and we've got the IDs of the two buttons there. Okay, so that's all of the initialization code that we need for that tile. So let's go back up to our main method that we were working in before, and I'm going to drag in some code that will actually go initialize the tile and get us set up to look at those tile events. So here's the call to the method that we just looked at a moment ago. And then the next thing that we want to do is just set up those tile open, tile closed, and the button pressed events. And in each of these events, what we want to do is just go update that status field on the UI to say a little bit about what's going on. So we've got open tile, closed tile, and then in the case of the button press, we actually want to see what the ID of the button was, so we can see whether we're getting our correct button press events coming back. And then finally, the last thing that we need to do is tell the tile manager to start looking for those events. Okay. Now, one more little step here is to go grab those icons, and we'll just put those in our assets folder, and we're ready to go. So we'll fire up that application again, and we'll come back to this display. And now we will have some new UI on the band in a moment. So like the heart rate case, we always want to get the user's consent. We're adding a tile to their band, and we want to make sure that applications can't do that in a way that can't do that without the user's consent or awareness. So we'll click the checkbox there, and you see here on the band now it says syncing. We're adding that tile to the band. We're pushing those page layouts down, and as we move over here, you'll see there's our new icon. And when I press the button here, we'll see the opened event come up there. And you see we've got the on and the off buttons. So if I press the buttons, there's our button press events. Okay. So this is just a hint of what you could do. You can imagine more pages, vertically scrolling content on the pages. Lots of room here for various kinds of interactive scenarios that you might want to create. So that's all for that demo. And Ali, if you want to finish up here, then we can take more questions.
It's okay, I think. Thank you, Tony. So that was, as you saw, with 10 minutes of work and a little bit of understanding, of course, of the SDK. You can actually create your own tile, send pages into that tile, push buttons into that tile, and get data back from those tile. So you can build a creative, interactive experience, which is very unique to the Microsoft Band that you cannot really do in any other wearable that easily with such a simple interactive model. So the things that we talked about today, for those of you who kind of think like, oh, there's a lot of code and this, I don't know what the hell these guys are talking about. The SDK is available right now. It's on developer.microsoftband.com, and it's available for Windows. It's available for Android. It's available for iOS. So the only variable that actually lets you develop against it on any platform that you want to use. If you don't want to write different, or if you want your application to run on all platforms, but you don't want to write different applications, there is this technology called Xamarin, where you actually just code once in C#, and that Xamarin platform is essentially spits out applications on all 3 platforms. So if you want to do that, we also support fully support bindings for Xamarin. So if you are a Xamarin developer, you can just write your application once, and it'll run across all different platforms. We talked about the sensor access, creating of the tile, and personalization of your app. All of these things are supported by the Microsoft Band. I highly recommend you go to that site once you get your Microsoft Band, and if you're interested in developing for the Microsoft Band. There's good documentation. Everything that we showed you here is probably going to be, I think all of those samples will cover everything that we've talked about here today. So those samples are fully compilable. You can just drag and drop those into your Visual Studio or whatever editor of your choice, development tool of your choice. Just run those, step through them. It's very simple to see what the Microsoft Band SDK does. So when we shipped Microsoft Band and Microsoft Health in October, we had some key partnerships established with some of our partners in the services space. These were partners that we were sharing data with. Here's an example of how our partnership looks like with Runkeeper. So this is a snapshot of the Runkeeper UI, where somebody who is actually a user of Runkeeper actually can go in and look at, and he owns Microsoft Band as well. They can actually find out how much time they slept because the Runkeeper actually gets data from Microsoft Band. Also other things like how many calories and steps they've taken, and also about the activities that they do during the days. So this is data that Runkeeper normally would not have had if you're just a Runkeeper user, but now you go in and buy a Microsoft Band, and because we have this partnership, your data starts showing up without you having to leave the experience of the partner. So your Microsoft Health data is coming into Runkeeper. So if you used to go to Runkeeper every day, you can still go there and get all of the data from Microsoft Health. We have similar partnerships with other providers like MapMyFitness, recently with Strava, and also MyFitnessPal. These partnerships were done in a very hand-holdy kind of fashion, where Microsoft and these partners work together, and we exchange data through this service called Data Exchange. That service is not something that a third-party application developer can use, but we wanted to bring third-party developers into this ecosystem as well. We want our developers and researchers to get data from Microsoft Health and basically enhance the experience of their own applications by using the data of Microsoft Health. This would allow all the users who are already have existing partnership with other apps and services like Runkeeper, or it could be any other application, to still be part of this ecosystem and get their data all in one place. So in order to do that, what we're doing is we're working on building a rich set of APIs, we call them the Microsoft Health APIs, to allow you to get the data from Microsoft Health and enhance the experience of your applications or your services with that data. So things that we can actually do is you can get sensor data collected by Microsoft Band and view it in your own service or application. In addition, you can actually, by getting this data, you can access and track your fitness, the fitness of your users more comprehensively. So not only do you get data that you normally get from your own service, you will be able to get data from Microsoft Health, so you will have a more holistic and comprehensive view of the user's fitness. Yes, sir, there was a question.
Yeah, does this mean that you're always sending data up to the cloud? Is that a user commit opt-in? Is that the developer opt-in?
So when you buy the Microsoft Band, your data does go to Microsoft Health, which is a service hosted by Microsoft. That is an implicit consent that you have to do when you install the Microsoft Health app and you go through the UBI process and pairing with the Microsoft Band. The data going to other parties like MyFitnessPal or Strava, the user actually has to go in and authorize all those applications on an app-by-app basis. So we won't share any data with anyone else unless the user goes in and says, okay, no, I do biking with my Microsoft Band, but I'm a heavy user of Strava, which is a very good app for doing bike data analysis. So you go in and say, okay, hey, Microsoft Health, can you actually tie my Strava account with Microsoft Health account? And that's when Microsoft will start sending data to Strava on your behalf.
And how does the connection between the phone and the cloud work? If it's streaming it, is it batching it?
It's batched. So because you can go for a run with Microsoft Band, not take your phone at all. So Microsoft Band actually collects data and keeps it on its local log storage. Whenever we get a chance to connect to the phone, we take the data from Microsoft Band and we send it over, we batch it up and send it to the cloud. And then the cloud basically has the ability to take the log file apart and look at all the events and all the data in the service. Thank you. Yes. So for streaming, your app doesn't have to send data to the cloud. So if you're specifically talking about data that your app actually is getting from the Microsoft Band from sensor streaming, that data you can choose not to send to the Microsoft. You don't have to actually send it to the Microsoft Health Service. You can send it to wherever you want to. As for just generally when we are tracking data, like I said, we store the data in the log file. So even if we're doing 60 hertz accelerometer, we don't send the raw accelerometer data to the cloud anyway. We send data by doing some computation on the firmware on the Microsoft Band. So if you're calculating steps by using the accelerometer, we'll actually log the steps, not just the accelerometer values in there. And then we'll send that step data over to the cloud. For heart rate, we'll send you basically 1 hertz heart rate. So does that answer your question? Okay, thank you. So yeah, using the health APIs, now your apps and services can actually get data from Microsoft Health and give the users a much broader, comprehensive view of their health. In addition, in the future, you will also be able to contribute data into the Microsoft Health. So if you have an app that communicates with a device that the user uses outside of the Microsoft Band and that collects some kind of health or sensor data, you can actually contribute that data into Microsoft Health. By doing that, essentially, we're building an ecosystem where Microsoft Health has a very rich data set. And once we have that ecosystem in place, it will appeal to all the other application developers to when they target Microsoft Health, they're not only targeting and appealing to the users of Microsoft Health and Microsoft Band, they're also appealing to all the partners of Microsoft Band, all the partners of Microsoft Health, and also the users of those partners of Microsoft Health. So some of the data that you can get as researchers, the data that you would be interested in are listed in this slide. So things like the user profile, for example, the user can authorize your application and give access to their Microsoft Health profile to your application. So now you'll know what their height is, what their weight is, what their gender is, and what their age group is, without them to having actually give that data again to you and basically managing that data in multiple places. You can just get that data from Microsoft Health. You can also get data from the sensors. So you can ask for historical data for like, okay, I want to know the heart rate for this user for the past week. So those are things that you can get through the summaries. So you can get hourly, daily, weekly, monthly summary of some of the steps, calories, distance, the things that we looked at, all the data that Microsoft Band collects. You will be able to go back and ask for historical data about that user in your own service. So you never have to write an application to talk to Microsoft Band to get that data. You can actually get that through the Microsoft Health service. These are RESTful APIs, which are basically open and following all the standards that everyone else follows. So they're very easy to write. Another thing that we can expose is activities. So basically, if someone went for a run or a bike, so for example, Strava gets the activity for the bike ride that you've done, your application or your service can also get data about the user's exercise and activities. So if you're providing some value to the user and you want to know what are the activities that these users do, you can just get that data from the Microsoft Health. You can also get data. Sleep is another activity that we talked about. You can also get the sleep pattern and sleep tracking activities from Microsoft Health into your application. Last but not least, things that they're using, the other devices that they're connected to, you're also able to know. So if someone is using Microsoft Band as well as using maybe a Jawbone or some other connected device that is connected to Microsoft Health, you don't have to worry about getting data from individual service. You will actually know that Microsoft Health has data about all of these other connected devices already in it. So you will be able to get those data. These are things that we're working on, and we'll probably have these in preview in the summer. So please, if you're interested in these, keep an eye out. If you have any suggestions, do let us know, and we can incorporate those into the mix. I think that was all that we had. I can take questions right now, and also I think at the end we can answer questions after Desney is done. So if you have any questions right now, yeah, sure.
I have two questions. One is, since you've been using the band for all the time, can you talk a little bit about the trade-offs between putting the band on the left hand versus the right?
Trade-offs in the sense, if you wear it on the dominant hand versus the non-dominant hand. Personally, I wear it on the right hand, which is my dominant hand. I don't see any reason why most of the data will be any different. One of the things that I did notice was when I wear it to play tennis, if I wear it on my dominant hand, because there's an extensive amount of movement going on, it's difficult for the band's LEDs to actually lock in and get a good heart rate throughout the period of time. So for those activities, when I go play tennis, I put it on the left-hand side, because then the heart rate doesn't change if it's on the right or the left. It's just that it's easier because there isn't a lot more movement on the left-hand side. But otherwise, it's just purely up to the person actually who's buying the band. The reason I wear it on the right-hand side is because I still want to wear my watch on my left hand. So.
The other question that we get a lot is, does it matter whether the screen is kind of on the inside or the outside as far as the heart rate readings and so on? And it really doesn't matter, it's just personal preference.
Yes.
But it's really kind of designed with the idea that it's on the inside of the wrist, and that's a very simple motion. It's easier to read the display that way.
And my second question is about pairing. So you actually, in the first app you showed how the app on the phone locks in on the bands, and that worked because there was only one band. But from a security standpoint, is there any support in the API for doing some sort of challenge response with the band, or that's left up to the developer?
Well, that's left up to the Bluetooth stack. Yeah.
So yeah, when you pair the band with the phone, that's when the challenge happens. So you basically at that point, so the implicit assumption is that the user has already authenticated or authorized the band to be connected to the phone. Yes. Yes, sir.
One of my colleagues actually bought the band and she slept with it, and she counted 80 steps on one night, and she was scared. So is the step counter sort of, is it really that it counts steps only when you walk, or are there errors because of rolling on the bed, or?
I don't want to scare your friend any more than she already is. I have never had false positive steps. Have you ever had experiences
No,
of steps?
I haven't seen that.
Maybe so if you wake up in the middle of the night to go to the restroom, you are taking steps at that time. So maybe she did go and take some steps.
Okay. So there's not much spurious.
There's always, at the end of the day, we're just analyzing accelerometer and gyroscope data. So it is easy to, if you know exactly the patterns that appear, you can fool the band into thinking that you're taking steps. However, we have optimized to a point where if you're sleeping, it should definitely not, or if you're working on a computer when you're typing, or if you're just not walking and just standing and gesturing like this, it doesn't calculate any steps. So my guess is that she probably did wake up to go to have a drink of water or use the restroom,
Okay.
and kind of forgot about it in the morning.
Sure. Yeah.
Yes, sir.
Can I ask how you do some calorie estimations? Does it take into account steps upstairs to go out to or something?
Sorry,
Do you know the difference? Do you know the difference between steps on the flat and steps going upstairs, and the work involved in lifting yourself up? Is there an alternative?
So hiking is difficult for calorie estimation because you're not moving very fast, but your heart rate is going up. So when you're running, your pace or your intensity of your run can easily tell us that you're burning more calories. So it's easy to estimate. For hiking, I think the algorithm team has optimized it to kind of figure out a true calorie burn when you're hiking, even though the speed is low. But yes, the question is good that there is a distinct difference where the intensity is there, but it doesn't show up in the obvious signs. I haven't gone for a hike with the band, but I'll ask around. Maybe I can tell you later. Yes.
So just a quick question. I might have misunderstood, but does the device store any data that you can later recover, or does it only stream data?
No, so device actually stores data. The streaming is supported through the SDK, but when I'm wearing the band right now, it's all the data that is being collected on the band is being stored on the band. Unless an application actually asks for a stream, we will not send any data over the stream. So the way it works is we get the data collected on the band. Anytime when the phone gets a chance to connect to the band or our application gets a chance to run, we extract the log file from the band and then send it to the cloud for more processing.
Okay, so the follow-up question then is, some of those sensing points must be much more energy expensive than others. So is there published frequencies, or can you change the frequencies?
On the data the band stores?
Yeah.
No, you can't change the frequency for the default because those are optimized for the algorithms that we actually have running on the band.
Okay.
But yes, you're absolutely right. If the way the heart rate, when you have the heart rate sensor working, the LEDs come on and they're staying on for while you're collecting heart rate. That's extensive and draws a lot of battery power. So we've optimized it for when you're sleeping. We don't continuously keep it on. We keep it on for a few minutes and then turn it off, and then it comes back on. But when you go for a run or when you're biking or doing a workout, during that time we're calculating every second. So we've optimized it like those things.
Okay, thank you.
Hi.
I'll come to you. Yes.
Sorry, I'm not sure if you've answered this already, but is the GSR sensor used for anything at the moment? I haven't heard you mention it, I don't think.
So GSR sensor is on the band. We don't expose it through the SDK right now.
Oh, you don't? Oh,
Yeah, it's unfortunate. When we were doing the work to expose a lot of the sensors, GSR came up as one of the things, and we just decided that we don't know if this is going to be useful. And we've gotten a lot of feedback that people want it. But right now, the way the SDK works right now, it doesn't expose it. But the band does have a GSR sensor, which we also use to figure out if you're wearing the band or not wearing the band, just because the impedance changes.
Oh, that's what it's for. Okay.
Yeah.
And so will you be exposing it at some time?
The plan is to at least look into it and see what we can do in a meaningful way. We don't want to expose the raw number because that might not be very useful. So we are looking at the way in which we can actually expose it in a way that people can understand. Because the variance from person to person is very different for GSR. One person wearing it and getting a certain number might not be the same number for another person. So it's hard to kind of make an algorithm that works. It has to be kind of like a trend of whether it has gone up or it's gone down, something like that. We're working on those, yes.
Well, and people frequently wear the band with different kind of tensions through the day. I know when I go for a run, I kind of cinch it up so I get a really good heart rate reading. But during the rest of the day, I'll frequently loosen it up, and it may be very loose on my wrist.
So the sensor is great, but it's hard. It's difficult to use because the conditions change so much. So, yes, sir.
Just to follow up an earlier question, what is the delay between the sensor band collecting the data and the time that it will show up in the cloud, that you can actually query it without an app on the phone or anything? Assuming your phone is right next to your band, right?
The platforms actually have different frequencies. On Android, I think it's less than 15 minutes. On Windows Phone, it's about 30 minutes before the data shows up. Up to 30 minutes, because that's when they schedule that background task. And I think iOS is similar to what it is on Windows Phone. Do you know the exact frequency?
I think we try to ping every 10 minutes.
Every 10 minutes we try to ping,
yeah,
but the resources on the phone dictate whether the phone is willing to give your task a chance to run. So if the user is watching a YouTube video, for example, the phone might say, I'm not going to run any background task because it's going to interfere with it.
But the data is not lost.
Data is not lost.
No.
You can.
Is there a published spec on all the stuff that's on the server? Like on what all of the sensors and the meta sensors or whatever you have on the server?
There will be. When we expose that API,
Yes.
that'll all be documented.
The data that is in the server that is accessible through the APIs will be documented. All the data that we collect in Microsoft Health, we probably won't, there's a lot of telemetry stuff, that we collect. There's other crash dumps and other things. Those things we obviously don't want to document what those are. But anything that you will be able to access using the APIs will be properly documented. Yes.
Who owns the data?
So the user owns the data.
Is it encrypted on the cloud? Is it without some credentials, nobody else can access it, or?
Yes. Even, so the data is protected by your Microsoft ID. So the way we authorize any third-party application to get data on your behalf is by giving them a token that expires after a certain amount of time. Without that token, there's no way you can get access to that data. In terms of actually going in and looking at the data, even within Microsoft, in our production class, everything is audited, so I can't go and look at your data, for example, unless you give me authorization by saying, okay, here's my token. Even if I look at data, there's no way for me to identify who the person is, because we anonymize it inside of our cloud as well. Yes. I don't know if does that.
But you're still able to do statistics across everybody, right? So you are, even if you strip out the PII from it, anything personally identifiable, you're still able to look at the stream.
Yes. Yeah. So we can anonymize data. We can look at, yes. So in order to make decisions about age groups and kind of behavioral patterns and those things, and but we have no way of knowing which data belongs to which person, unless we know your exact token. Yes. There's a question.
This
Oh,
side,
sorry.
the other side of the room for change.
Yeah.
Maybe somebody has already asked this, but can you? I assume you can connect multiple bands actually to the phone?
Yes.
I was wondering whether you have tools that provide actually kind of on that level of abstraction some useful information.
Tools that.
What kind of abstractions are you thinking of?
For example, movement frequency improvement in step counting. If you put this to your ankle, for instance, instead on the wrist, or if you put both hands on the wrist to identify certain things that you can use your hands.
No, we haven't done that yet. There are some folks within Microsoft I know who are interested in that. There was a hackathon within Microsoft where some folks were working on gesture recognition. So, looking at that sensor stream and then detecting different, kinds of motions.
That would be a viable thing to try out, for example.
Yes, absolutely. Yeah, I think it would be very interesting to have a component or a library that sat on top of the SDK and could provide you those higher level abstractions. Yeah.
Exactly. Yes.
So you said earlier that you don't only provide the data, but you also provide recommendation on how to act on your data. So I have the same problem with this kind of device than with 23andMe, which is there is nothing validated by doctor or by scientist. So you give me data about my sleep, I go on the internet and I find 25 definitions of deep sleep, light sleep, the different notions of, and I don't know what to do with the data. So are you working with doctors? Are you working with other scientists to validate your data? And why should I trust you? And are you sure you give the same data than other ones? Because it's proven for 23andMe, for example, that if you do the test with another company, you get completely different genetical data.
Yeah, so if I understand the question, there are two questions. One is, how do you know that the difference between the different kind of things that we're recommending, whether they are scientifically correct or medically correct? And the second thing is, why should you trust the data that comes from So the matter of trust is we validated and we do tests against the ground truth in order to develop our algorithms, for example. So when we did the heart rate, we validated against the polar chest strap. And I think that if the variance differs depending on what the heart rate is, but I can tell you that we are within the 3% margin for polar on an average resting heart rate reading. So, and we've done that extensive testing on that. So I don't know if there's any standard that can actually prove whether this device has a heart rate monitor or not, but we can actually publish those, or we talk about those things publicly where we say what kind of testing we've done. So data is trustworthy. We've done sleep studies where we actually observe some people who are sleeping with their actual, whether this person was moving or not moving, and then correlating the ground truth with the sleep data. The second thing is the definition of certain things like deep sleep, light sleep. Those are, that's a tricky subject because you're right, there are 3 or 4 different definitions of how people define REM sleep versus non-REM sleep versus deep sleep and light sleep. So the things that we highlight as the Microsoft Band, we don't claim anything about your REM sleep. We don't make any statements about non-REM or even deep sleep. The 2 things that we measure are your light sleep and restful sleep. And those are the ones that we can actually accurately determine using the band. So there are other devices that actually classify things as deep sleep, which is very different from the definition of deep sleep. Some people think that restful is the same thing as deep, which it's not. And some people, there are devices that actually say REM sleep, which are probably just guessing at best, according to our tests at least, about the REM patterns of people. So, I mean, you have to trust that a company that is selling a product and taking pride in it probably will do the right amount of testing to earn your trust on that. Thank you. Yes, sir.
You have mentioned that the data is stored on the band. How much data can you actually store on the band, and what happens actually if the band runs out of memory?
Okay, so the data that you store on the Microsoft Band depends on the kind of things you're doing with the Microsoft Band. If you go for like a 3-day run with the Microsoft Band, that's a lot more data than someone that's like an average user that just walks around with the band during the day. We do calculate on an average day about 800,000 different data points on a human that is wearing the Microsoft Band. We log about 80,000 of those inside of our log files. With that kind of a usage, we can store up to about 2 weeks of data without actually syncing. So once it syncs, we delete it from the band so we free up space. Once the log file is full, we will just, basically it's a circular buffer, so you'll start losing the earliest day's data. And it's just, but I mean, if you're not syncing for 14, 15 days, then there's probably, you need to kind of have, you have to sync at some point. I think we're starting on, I think, Desney's session. We can come back after Desney's session to answer more questions. I'm sorry, because I want to give him the maximum amount of time that he had. So thank you, everyone, and we'll answer more questions after Desney's session. Thanks.
Nope, other one. Thank you. So these 2.5-hour sessions are long. So I get to be the future work section, if you will. If Shwetak sort of opened up with the introduction, and Ali and Tony gave you the meat of the tutorial, think of me as the future work section. I also have the pleasure or ill pleasure of standing between you and coffee, and probably more importantly, between you and your free bands, which I was nervous by initially, but I guess I'll take the captive audience. So I wanted to chat a little bit about Project Aurora, which is a research project that we've been doing looking at continuous ambulatory hemodynamic state assessment. But before I did that, I wanted to, let me see if I can get my pointer here. I wanted to sort of convey the exciting times it is at Microsoft these days. So we've got a reasonably new CEO. He's been in office for a year or two now. And it's kind of a fun time because he's a CEO that's come in post Bill Gates and Steve Ballmer, who were the initial founders of the company, and really sees it as his job to rekindle growth and innovation within the company, which is just a wonderful, refreshing sort of mindset for the company to get into in this phase of its life cycle. Additionally, as we sit in Microsoft Research, it's a great time as well because he's got a war chest of resource that he's willing to exercise. In fact, resource continues to flow in. The company's still making good money. And at the same time, he's trying to use it to create growth and innovation. And what better time to be in an industrial research environment than having money flowing in and the ability, willingness, and desire to spend it on growth. So here's a quote that captures it fairly nicely. in a memo that he wrote when he first took office. He said, our industry does not respect tradition. It only respects innovation. Then he goes on to say, we embrace what only Microsoft can contribute to the world and how we can once again change the world. And how he considers the job before us to be bolder and more ambitious than anything we've ever done. This is a company that took Windows and put a PC on every desk in every home. This is a company that started from nothing and grew up an Xbox business. This is a company that's done a lot of wonderful things. And we're on a bolder and more ambitious mission than ever before. Within MSR, so you heard Peter speak this morning, I think there's one quote that I particularly like that captures our philosophy fairly nicely. So Peter said that we celebrate innovation, as Satya has sort of called for, but that's not really enough. Innovation by itself isn't going to get us to where we're going. We reward execution, so we got to get stuff done, we got to get stuff out there. But that alone isn't enough. What we really worship is impact. It's taking that innovation, taking that execution, really getting it out there. And impact you can define in a multitude of ways. There's sort of growth in number of users, there's impact to those users, there's game-changing paradigm shifts, there's of course money, just a whole series of metrics, but really what MSR stands for is this end-to-end process of innovating, executing, and then creating impact. So our group in particular, I just wanted to give you a quick history, and this was supposed to be a build, but it looked like I mucked that. There are three basic areas we work in. There's mobile interaction, and the approach we've taken has been a very on-body or wearable-centric one. So using wearables and on-body interfaces and devices, can we really move beyond the keyboard and mouse and touch screens, and can we create rich sets of gestures and speech and what have you? And we've got a bunch of projects in that space that I won't talk about today. A second agenda that's sort of run through the work in my group is interactive machine learning. So the idea of involving the user in these machine learning loops to be able to take data, raw, processed, or otherwise, to create, as Ali and Tony have sort of talked about, actionable insight. Can we take that data, can we use machine learning and create actionable information and insight? And then the third agenda, which is the one I'll focus most on today, is this health agenda, which has grown to be the bulk of our work. Initially, it was sort of a bunch of explorations in devices, some in health informatics, and eventually we sort of combined the interactive machine learning, the mobile interaction, or the devices work with our HCI backgrounds to create a whole bunch of projects in this space. A lot of that resulted in work with Ali and Tony and the band team, looking at a couple of things, and then I'll talk about Project Aurora after that. But many teams have worked with band from within MSR, so Ali and Tony sort of mentioned the Cortana integration that Tim Peck, who's not in this room but around here somewhere, has done. Eric Chang is somewhere in here, I believe, right there. So he's been working on some of the sleep algorithms from our Beijing lab. My group looked at two things. So one was the automatic exercise analysis, which made sense given our deep expertise in looking at activity recognition. And so we went about not only detecting that you're exercising, but categorizing the exercise you're doing and then counting it. Because who really wants to be scribbling down little notes in their notebook as you work out? So it was fun. We had a bunch of algorithms sitting around, but it turns out that, and you'll see this recurring in many talks. So there's sort of the basic science that happens. There's a big gap in between, and then there's the product development. And filling that big gap is both a fun, exciting, but also very difficult exercise. And so things like, this worked perfectly in the lab, the first number of times we did this and as we did the basic science. And when we started deploying in the real world, everything just broke. People don't do what you do in the lab in the real world. They walk around, they drink water, they sort of do all sorts of crazy actions. And it turns out we had to go back nearly to the stage of the basic science to rethink the way we collected data, the way we trained data, the way we developed algorithms, the way we made them robust, so that they worked on the small people and large people and tall people and short people, people who were reasonably controlled in the way they do their exercises, people that were all over the place. And so that was sort of a fun exercise. We also looked at the science of heart rate. Again, similar thing, we had lots of algorithms that worked fairly well in the lab. As soon as you get outside, you see the heart rate signal starts to look fairly different than it does in the lab if you're sitting still. You've got these peaks, you've got these high frequency noise sources that you get, you've got these low frequency drifts, you've got repetitive action in the real world that start to look like heart rate as the band moves around on the wrist. And so you get an extremely varied signal with motion robustness being the most difficult of the problems that we've partially solved but have some work yet to do. So, I'm not going to talk about this too much, but the approach we took was one that allowed us to do on-the-fly and live signal quality estimation with a number of heuristics and learned algorithms. So we run a bunch of these in parallel. We start to feed in, and so we can tell when we're confident enough to display the heart rate, when we've got a good lock. We determine when we can rectify bad heart rate signals, and importantly, we also decide on the fly when we have to throw away data because the data is just too noisy. So taking a step back, let me give you sort of the 10,000-foot view of how we think about the health market and how we think about our roadmaps moving forward. Here's where the band is, and here's what we've been talking about. We're talking about consumer devices and services in consumer form factor, and we've built, starting at that point. Couple of properties here, as you guys are fairly familiar with. So there's fairly low barriers to entry here, which is why you see such a crowded space. It's becoming easier and easier to make hardware. It's becoming easier and easier to write software. It's becoming easier to integrate. And there are things that are still challenging, but this is a reasonably crowded space. Wonderfully, there are potentially very high volume. Anyone can buy and use one of these things and get value out of it. But it turns out because of the crowd in the space, the margins in the space tend to be reasonably low. The wonderful thing about sitting in MSR, and this was sort of my team's story, was that when we got done sort of working with the team on the V1 band, we sort of took a step back and we said, look, the band's sort of running. These guys are highly effective. They continue to iterate on this thing. They continue to improve and add lots and lots of value to it. What do we as a research unit do? And so the way I think about research teams is, or one way one can think about research teams is that we're, to use an army analogy, we're special ops teams, right? We can craft and recraft very quickly. We're teams typically fairly small, highly effective, teams that work together very well. But interestingly, in the industrial setting, we're teams that you can extract from core tasks like this, getting the band out there and continuing to ship it and sell lots of them. And we can inject ourselves in new places fairly quietly, to go explore whether the main unit should steer into it or out of certain areas. And so the area we decided to get into was at the top of the stack or the side of the stack or the bottom of the stack, depending on how you position the stack. But the medical devices and services space. So these are typically devices that are on the higher end. They're heavily outcome-based, heavily validated. In fact, so much so that they're typically regulated by various bodies. Here you see the flip. The volume tends to be a lot lower in these markets, but you see much higher margins. And the reason we dropped our team in that space, and you'll see this in Project Aurora in a couple of minutes, was not so much because we wanted to turn Microsoft into a medical devices or a medical services company, but because this is the space we really care about. It's the space in between the two, what we call the prosumer medical wearable space. The prosumer term comes from cameras. So you've got, in the camera space, you've got your point and shoot cameras, your consumer-based cameras, you've got your SLRs on the top end. And these days, you've got very high-end consumer cameras that look like SLRs or SLRs that are accessible to your consumer space. And there you get the best properties of the two. So you've got outcome-based devices and services. You might or might not be regulated, but you might be able to tackle high volume with reasonably high margins, which is the interesting thing to us. So this is the team. This is the Microsoft Medical Devices group that I run. It's a bunch of folks. There are actually 2 folks that organizationally don't live with it in the group, but we bring them in as ringers. So Shwetak Patel at the University of Washington works very closely with us and sits with us and looks just like us. And Nick Villar, who's somewhere in the room, there he is, he's out back, who lives with the Microsoft Research Cambridge group. But the core mission, as we see it right now, is to leverage our expertise in physiological sensing, human activity analysis, and wearable device development in order to significantly improve human life and health in some way. So when we started the group, sorry, I'm using a mouse rather than a pointer, and I'm moving the pointer around. We had to sort of look at the high-level philosophy of what we're doing and why it was that Microsoft was getting into the space. And as engineers, our first inclination into the space was that we were trying to improve health, but when we looked in, there were actually very few ways to measure and track that. And so if we believe that we can't improve what we can't measure, then the first job that we have in this space is to be able to measure the things that are appropriate and that are important to measure. And so we see our task as first digitizing the analog world, the human body and or the environment that we're operating in. After which we can apply all the things we have as computer scientists to be able to compute, and all toward the goal of detecting, diagnosing, managing, and hopefully eventually predicting and preventing disease. So fairly simple high-level statement. The goal then is to move from a very intuitive-based medicine, something that humans observe, something that's fairly subjective, to a system of more precision medicine. Right? So let's turn at least parts of medicine more into data science. So we took a step back. We looked at the disease landscape and pick whatever metric you will. Pick number of incidences, pick number of deaths, pick cost to system, seriousness of disease. You'll see that the pie chart roughly breaks down into this. Right? So about a third of the pie is cancer. About a third of the pie is cardiovascular disease, and about a third of the pie is everything else. Cancer turns out, at least the way Microsoft has posed it, to be largely a genomics problem, and we've got a bunch of groups working in that space, and I won't sort of touch on that today. Our group decided to tackle cardiovascular disease, and I'll tell you why in a second. But just to give you a sense for the numbers, each year in the U.S., 84 million people afflicted with cardiovascular disease of some form. We have greater than 600,000 deaths. This is, again, annually in the U.S. alone. That's over 2,000 deaths a day. In the time that we've been talking, we've probably seen about 300 deaths in the U.S. due to cardiovascular disease. And obviously, that comes with extremely high costs. Billion, thank you, Gregory. Yes, turn the M into a B on the dollar sign. This is about 17 million deaths globally every year. So it turns out if you look at cardiovascular disease, it's a whole slew of conditions. Everything from coronary heart disease, which is one of the more prevalent ones, arrhythmias, you got heart failures, heart valve disease, the list goes on and on. And so tackling cardiovascular disease itself sounds simple, but given that it breaks down into a whole bunch of stuff, we sort of had to find a vector into the space. Here's the vector we've chosen and one that made a lot of sense to us. If you look at most of these conditions, they share one thing in common. So this is your artery. As an engineer, I sort of, at a high level, like to model things. And so think of the heart as a pump. Think as your vascular system, your arteries and your veins as pipes. Those pipes are flexible, and those pipes are dynamically controlled as you do various things, as you sit and stand and walk upstairs. Your body regulates the flexibility and stiffness of your arteries to be able to get blood and oxygen to where it goes. Well, if you look at most of these conditions, What happens as diseases progress is from the left, you see normal, well-functioning arteries. They look great. They flex when they have to. Your body dynamically controls them. As disease progresses, you start to see fatty streaks within those arteries, and then you see plaques start to build up on the inside and outside of them. And eventually you see stenosis, where you've now got a tube that's stuffed. And so your heart's having to pump really hard to get the same amount of blood and oxygen to various places, which tends to be bad for the heart. The good news is that there are many treatments available during the course of this progression to either slow or stop, or in some cases slightly reverse the progression. The bad news is that with today's techniques, we don't really detect this progression until it's pretty late. But by the time we see symptoms, you've got hypertension, you've had a heart attack, you've had a stroke, and we can only reverse the action by so much. And so the goal then is to detect it as early as possible so that we can intervene, either with behavioral or medication. Oops. So in detecting arterial stiffness, if you look at practice today, there are multiple ways of doing this. Most of the way you would detect arterial stiffness in practice today is invasive. You would catheterize a patient, you'd measure sort of the various metrics that you would measure, or expensive in that you would have to do fairly involved imaging. There are these two metrics that have sort of popped in and out of the literature that we decided to go after. So one is pulse wave velocity and one is augmentation index, and I'll go through these in a little bit more detail. These can be done non-invasively. In fact, these, it turns out, can be done from a single point on body. And it's been shown that these metrics, even non-invasive metrics of arterial stiffness, are predictive of cardiovascular disease, or as predictive of cardiovascular disease as all the other metrics that we measure today non-invasively combined. So things like age, gender, blood pressure, heart rate, cholesterol levels, whether or not you're a smoker, the medications you're taking. So we measure all this today to get a sense for cardiovascular risk. And it turns out that if you can measure arterial stiffness, you have a predictor and a metric that's at least as good as all of these. In fact, better than that, if you combine the set of things that we already measure with arterial stiffness, you improve your predictive power even more. So they're nice and complementary as well. So we're going to set out to measure these two metrics. I'm going to tell you a little bit about them in a second. Let's go into pulse wave velocity. The pulse wave velocity defined is very simple. It's the velocity of your pulse wave measured from some point on your body to some other point in your body. Pick any two sites. So to do this, estimate the distance between the two sites you've picked. Measure the time it takes for that pulse wave to travel from one point to the other, and divide. Calculate velocity. Today, this is typically done from the carotid artery to the femoral artery, so from your throat to somewhere around your groin. This is done with a tonometer. So it's a pen-like or stylus-like device with a pressure sensor on the tip. So you touch it on the 2 points, and you measure the time that it takes to get between the two, and you measure the distance, and you get the velocity out of that. So inconvenient. I mean, these devices turn out to be extremely expensive for little good reason, but it's also amazingly inconvenient and requires quite a bit of expertise. So imagine putting a pressure sensor that you're manually holding, on 2 points of the body. They've made it much simpler these days, so they use the EKG as a clock, if you will. So you do it on one point, measuring while you measure the EKG, you do it on the other point, and then you sync the two signals. But not used in practice a heck of a lot, just because of the expertise and the time that it requires to measure. We've had years of work, sort of peaking in the last 10 to 15 years, correlating these signals to a whole bunch of conditions. So, the point of this slide is not to read through each of these, but to look at the large categories of disease that folks are working on and have shown good correlation and predictive power with. So coronary artery disease, renal disease, diabetes, heart failure, stroke, some of the major ones. And the list sort of goes on, and the work continues to grow. So this is what we have. The way we've chosen to do it, because of the form factor and the difficulty of doing that, continuously, which we think is important, is we've looked at radial pulse wave velocity. So the basic idea is this: what we'd like to do is pick the two sites as the heart and the radial artery, or the wrist. The way we're going to get it at the heart is we're going to measure an EKG, so the electrical activity of the heart. If you look at the R wave there, that basically tells you when the left ventricle is contracting and ejecting that pulse wave. If you look at the pulse wave at the wrist, you then get the second point, and you can measure the time in between those two. And it turns out you can measure all those things from the wrist itself. Same thing, in case you're wondering if the periphery actually correlates to the kinds of conditions we care about. There are two things we can do here. So there's been a lot of work looking at the peripheral signal itself and correlating that to disease. But we could also build a transfer function to map the peripheral pulse wave velocity back to the central pulse wave velocity, which then brings us back into the other body of literature. So that's pulse wave velocity in a nutshell. Let me talk a little bit about augmentation index. So if you put your finger on your pulse on your wrist, we've all done this, doctors have all done this, you'll feel what looks like a pulse. So you'll think of the signal of something that looks kind of like that. If you count those beats over time, you get a heart rate. If you're a little more sensitive to it, you can look at the variance between those beats and get heart rate variability out of it. Well, it turns out, again, going back to the model of the pump in the tubes, that signal measured at the pulse at the wrist is actually a much richer signal than just a pulse. And it makes sense. If you think, again, of the pipes, the pulse pressure has to go somewhere. It doesn't just dissipate at the ends, so there's a reflective wave that comes back. Now, if you look at the reflective wave, which is called the anacrotic notch, at the wrist, you'll see the second bump as the wave comes back at the heart. If you actually insert a catheter in the heart, what you'll see is that reflective wave is actually quite large at the heart. And if you're worried about how hard the heart is having to work, it's having to work against that reflected wave coming back at the heart. And so that's what we really care about. And so looking at the full pressure signal at the radial artery and looking at the various characteristics, amplitudes and times within the radial signal, we can derive, again, a good metric of arterial stiffness and the work that the heart is having to do to work against that. Right, and so again, that can be done with a tonometer. Good news is that the peripheral augmentation index, if you look at the peripheral signal, has been shown in prior work to be very well correlated to the central augmentation index. And so again, wonderful that we can measure this at the wrist rather than having to insert catheters or anything like that. And again, suggests a form factor that we can pack this thing into, in which we can continuously measure these fairly key metrics out in the real world. So augmentation index similarly, don't worry too much about the details, but very well correlated to various of the conditions we care about. Coronary artery disease, renal disease, diabetes, hypertension, and so on. So what we've done is we've packed the ability to build this into a wrist-worn form factor, This is a very early research prototype that we've built and started to deploy. It's got your standard accelerometer gyro, again, because activity in the real world is so important. To be able to interpret some of these signals, we need to know what you're doing in the real world. So if you've run up a flight of stairs, that leads to a different interpretation of your signal than if you've been sitting there and your signal does something. We've got an ECG, electrocardiogram here. It's a lead 1 or 1 lead ECG. So part of the band is an electrode. We've made a flexible electrode. The other part is on the top of the face of the watch or the band. And so one contact on the wrist you're wearing the device on. Second contact you touch with your other hand, and that gives you a lead 1 EKG. And then we've got a radial pressure sensor that sits on the bottom of this device that measures the radial pulse pressure wave. And between these sensors, we're able to derive radial augmentation index and peripheral pulse wave velocity and do some pretty interesting stuff. Just as a spec, it's got a fairly low resolution LED display on it. Largely as a research prototype, we didn't want to get fancy with it. We wanted to get this out the door, get feedback, start to do validations. So we didn't build a fancy display into it. It also meant that we were able to be disciplined about not making this a full-blown smartwatch, which I think if we had put a display on, we would have absolutely gone down the path of. Haptic actuator, it's got a fairly beefy processor on it, good chunk of memory to store all our data, and then a Bluetooth radio to get this off board. So we did some initial validation. So here's a handheld tonometer compared to our device. The handheld tonometer required an expert to operate. The wearable tonometer required these specific instructions to a average consumer. We said put it on such that the radial pressure sensor lands somewhere around where you would take your pulse. And that's all we told them. And we got signals that look fairly similar. In fact, if you look at the correlation, this is very highly correlated. So that was sort of encouraging to see. Now, we've done a lot of validation, but rather than show you a whole bunch of charts, we thought we'd do a live demo of this. So Shwetak's going to pop up. And let me get this fired up. Do you have a device? So Shwetak's got one of these devices, and you guys can come up and take a look after the talk if you like. But he's got a device on his wrist. Let's go ahead and get that connected. Live demos. Sorry, I'm going to move it down because I can't see what I'm doing. Oh, you're not 115, are you?
No.
Sorry. Can you hit the button? Which unit are you? Oh, you're 101. Sorry, I've got too many devices paired on this. All right. Oops. So on the top, you see the pressure sensor signal. On the second row, you see the EKG signal, and then the 3 XYZ accelerometer signals. So Shwetak were to stand reasonably still for a while. You sort of see the pressure signal. That's that rich wave that I was talking about earlier. If you want to get an EKG signal on it, just kind of hold on to it. Sorry about the graph scaling. We're sort of dynamically scaling the graph so we get to see this. So it's inverted right now for a variety of reasons, but you see sort of the basic EKG signal. So very quickly we can sort of do, we can look at augmentation index. Oops, I came up on the wrong window. So again, augmentation index looks at this. It looks at the various key points and identifies the landmarks on this. And we start to average this out here. So the blue dots, the red dots are the anacrotic notch. And we start to detect those, and we can average and determine a peripheral augmentation index. And then just very quickly, we'll do a pulse transit time one, I guess. So if you can get EKG on that. I apologize, we flipped the pressure and EKG signal on this interface for no good reason. But you'll start to see us detect the 2 peaks. Here's the timing in between. And if we had measured sort of Shwetak, it's simple math to get the pulse wave velocity on this. And Shwetak's actually really healthy. So just to wrap, so we've run tens, nearly 100 units at this point of this device. We've started handing them out, mostly across. This is a little bit outdated, but mostly across the U.S. and Europe at this point, largely to do early validations. So looking at feasibility and reproducibility, looking at ambulatory studies, and then looking at predictive and interventions. So with respect to feasibility and reproducibility, what we're largely looking at is, does this thing do what we say it does? So we're starting to validate against other peripheral standards, so the non-invasive stuff measured by experts. We're looking at correlation with central standards as well. So we're putting these on catheterized patients. These in clinic are typically patients that are much higher risk because you don't typically want to open the body up to catheterize unless you know they're at reasonable risk. But correlating with these and eventually trying to push the set of people that we can collect these metrics with, further and further down the risk chain and making it more continuous as well. And then we'll start to build the transfer functions to map peripheral to central as well as we collect more and more of this data. Ambulatory studies, so it's interesting in that these metrics are sufficiently difficult to measure even in clinic that there's very poor understanding of what happens in continuous and ambulatory studies or settings. So what happens when you drink a cup of coffee, what happens when you're in the real world, what happens when you're sleeping, what happens on a 24-hour cycle or 48-hour cycle. These are all things that this device allows us to start to study. And we believe that these metrics, if measured continuously in an ambulatory setting, will give us much more predictive power because you can start to run things like natural stress tests. So I've just climbed up a flight of stairs. What is my cardiovascular system doing? Or I've slept, or like I say, I've drank a cup of coffee. Again, because of our expertise in activity recognition, we're likely to combine a good chunk of these with activity recognition to be able to better interpret the context in which we're measuring these signals and to really understand the fullness of these signals in a real setting. And then there's this notion of continuous availability, even if not continuous monitoring. So there are a bunch of these conditions where, arrhythmias, for example, where the events are fairly sporadic and they're kind of hard to measure. So I could put a Holter monitor or some of these patches on a patient. But unless you're able to catch the event itself, these things are not useful. And sometimes they occur on order of months apart or weeks apart. And you really don't want to instrument anyone with these sort of clunky devices through that period of time. But the patients are often, able and willing to detect these, and so if they can have these available, even if it's not continuously logging. So the question that comes up is the EKG and the pulse wave velocity actually a reasonable thing to do constantly because you actually have to touch it with your other hand? The answer is maybe, right? In many cases, if we just build the electrodes into the buttons of an otherwise smart watch, you can surreptitiously measure a lot of these as you're interacting with the device itself. But you can also trigger these events. You could remind the user to do it, or better yet, when there is an event that occurs, the user can very quickly get a measurement. And then pushing out, looking at perspective and in-clinic risk prediction, even outpatient risk prediction. Can we start to, as Shwetak was talking about in his presentation, can we start to detect these things even earlier than we do today? And can we start to treat them and stop them and reverse the effects much earlier in the cycle? And then there's this category of treatment management where we can really close the loop. Again, we're talking about precision medicine, where we can really close the loop once something's been diagnosed and is being treated. So today, in cardiovascular space, you might detect a condition, you might prescribe a medication or a behavioral change, and then you might check back 3-6 months later, and if it's working, you're good to go. If not, you start to tailor that, and you can really tighten that cycle, looking at even titration and dosing of medications on the fly if we're able to get good markers in the real world. And so to close, going back to this slide of Shwetak's, I do agree and believe that there is an explosion of wearable biosensing devices. The technology is there, our understanding of the physiology is there. We are at this wonderful tipping point. Trouble being that many of them fail to engage and deliver real impact today. The assertion we make then is that research, it's upon us to deliver this deep innovation. The way we go about doing this is treating the body as a prolific generator of big data, if only we can digitize it. and to put the onus on us to discover or invent high-value propositions. In our case, trying to measure new vital signs continuously. And I would claim as technologists, there's been no other time in which we've been quite as critical to healthcare as today. In fact, I believe we are going to be critical piece of the healthcare revolution that is upon us. So let's engage, grab any number of us over the number of days or weeks or months ahead. This is a large task for all of us. And let's do this thing. Thank you. So let's see, we are right at time. There's one more thing that we have to do. Feel free to grab us for questions after. We'll hang around. We are going to be handing bands out. What I'm going to ask is, in several batches, this is going to be a little bit chaotic, so forgive us, but in several batches, if folks that responded to the sizing emails will first go grab their devices. We can give those out. And then folks that haven't responded, there are other devices out there. I'll ask that the Microsoft folks wait till tomorrow morning to grab yours, just so we sort of let our academic partners grab theirs and get out of here and we can get to coffee. So we'll reach out and get the Microsoft ones out to you guys tomorrow. But thanks for your attention. Thanks for being here, and we look forward to more conversations.